show you which flower it is, but of course I wanted to show the stable diffusion version of it, not just the flower, to make it cool, right? Because that's a bit cooler. The other one idea I had for this simple prediction service is to say, okay, the service is going to run once a day. GitHub will show you a new iris flower every day. I wonder which one it'll be. But the point is, there's a model driving it, and you're building it and running it yourself. That's kind of the next step you want to take beyond just building data. In data science now, we just build models, and we think we're done. They have to be embedded in a service, and that service has to have value, and you can do it all in Python now, and serverless. So it's cool.
But if I understand it correctly, I mean, the iris dataset, you basically have these kind of features that you mentioned as numerical features, right? But then did you try to have some prompt, some text prompt saying, this is the pedal length or something, or how do you do that?
Well, so if you think you want to build this thing, a prediction service around your model, you need a UI if you want to do what we're talking about here, right? So actually, Hugging Face released the UI. It's called Gradle. That's a plugin to, you can just go pip install Gradle, and then it's in your notebook.
They acquired that, right? The company.
Yeah, they acquired the company, but it's a nice library, Python library. And if you've got a Jupyter notebook, or if you've got a Colab notebook, and in one of the cells you go pip install Gradle, you get a nice little UI. So, for a data scientist to go, oh wow, I'm not just trained a model and seeing a number which is the accuracy or the F1 score. I got an UI. I can enter values, click something, and it's going to show me the name of the flower. And you're going to go, hang on, do I have to show the name? Maybe I could show an image. You say, I'll show the image of the iris. Come on, let's be cooler than that. Let's show the diffusion. What does Dali think this flower looks like?
But what I take away here is actually how important it is that when we go to stakeholders or when we are trying to get something that is of value outside of the nerdy community, so to speak, we need to find ways to communicate and create excitement. And even to the point where someone goes to a course now and in learning about this, let's wrap it in a service and let's make it cool. That's the whole, and it's quite profound importance behind this little gimmick.
I think 100%. So if I'm trying to sell someone, let's say if you're working at a retail company and I'm building a recommender, and you get to checkout, and I'm going to recommend some things to just throw in your basket before you check out. And I say, well, look, I've trained this recommender system. It's fantastic. Increases conversion by 2%. And then the stakeholder goes, yeah, interesting. And then they go, well, what is this? And show them the thing, show them the basket, show them what it's recommending, and show them what it was like without it. And then that's such a different experience for a stakeholder to see, oh, look, now this is kind of a bit smarter. I watched Game of Thrones last night, and there's this new Lord of the Rings thing coming out, and that looks kind of interesting. And just showing it to people helps them understand it at a different level.
You mean it's not sufficient with tensor board graphs, or what do you mean?
What is a TensorFlow graph?
ML flow. No, but I really do. And the other thing, actually, there is another side to it, which is not just the stakeholders who will interact with it. You also have to work with the data people. And the data people often say to the AI people, well, come on, you're so naive. Like, you think you can use that piece of data? Oh, come on, So I think particularly people who in Python who develop models, they need more experience with getting data and writing the pipelines that generate the data. And you can do all of this in Python today. You don't need to leave Python. Because I think when people think, I need to leave Python to do my UX, you don't. You can use Gradle that I mentioned in the Jupyter Notebook, but there's Streamlit as well.
But you can do that at least to build prototypes, right? Or proof of concepts that at least have some way to give some kind of user interface that you can interact with. But, I guess we should put this topic later. But is that really sufficient to actually have something to put in production? Or how do you actually move from a prototype to production, given that you potentially use Gradle or something similar?
Well, I don't think Gradle is fit for production, but I think there are, depending what you're doing, right? So I'll give a pitch. I'm giving a talk next week on surfing in Ireland, right? So I'm from Ireland originally, and I love surfing, and I had a paper.
I think we have one more here.
Oh, cool. Even I'll one up you now. I had a paper at ICML on surfing in 2005.
Oh my God,
that's good.
ICML is like
goosebump stuff before we got started.
So, domain expert plus AI expert in surfing.
After work, I will tell you where I'm flying on Sunday. I will tell you.
You're going to leave it hanging like that? Come on. Okay. Anyway, so there's a beach in Ireland called Lahinch, and there's a person every day comes out and says the wave is too high today. The surf is 2 foot. It's 3 foot. It's 1 foot. And they do that every day at the same time. And out in the Atlantic, there's buoys or buoys that predict the height of an open ocean swell. Oh. They'll say the direction, the wavelength.
You're in my hometown right now.
And
which swell forecast?
Magic Seaweed's pretty good.
Magic
But it's
Seaweed.
not. If you want to go to the Hinge, you should go to my website. It's
so
called
you're way-
CJ Surf, and it's using AI to predict the height of the wave at the Hinge for the next 2 weeks.
And I can
it's
tell you-
running as a GitHub page. The UI is GitHub page.
Yeah, yeah.
All right.
So once a day, a pipeline will scrape the latest swell height predictions from Noah Boy.
Magic?
No, from Noah Boy.
Okay.
From Noah directly. So
Okay,
Noah,
real
the
Noah.
American,
real Noah
authorities.
Boy's authorities, yeah?
Yeah, they have some tabular data you can scrape from the website with the predictions for the swell height, the wavelength,
I'm
and
seeing
the
a
direction.
project coming on very fast.
You know, I did this as a project. Well, I'll tell you another story about this. Very interesting.
I need this product on Monday.
The person I did this with, Kieran Lee, he co-founded a company called Intercom, and I think he was on top 100 Irish rich list at some stage a few years ago. You know, so he was CTO. They're a $1 billion company. So, you know, he's moved on to greater things. So start with surfing, and you'll go. Anyway, the point there, just to answer your question, Anders, was that we have a UI. For me, that's a production system, right? Every day, it's going to download the latest predictions. It'll regenerate a UI with the graph of the surf heights, and you can just go and have a look. It's not beautiful. It's matplotlib graph, so it's ugly. But that's production, you know.
And I think it's agile as well. I mean, you start with the simplest thing that has an MVP at least, and then if it needs to be expanded, you do that.
It's a Python. It's all in Python, 100% Python, and it's using GitHub Actions to run every day.
And bottom line, putting something in production, how long is a piece of string? You know, what are you doing in production? Are you running a nuclear power plant, or are you checking out surf heights? You know, so it all depends, right?
Yeah, I mean, you can.
So I think
debate about value add.
You could basically have a statement. For some cases, Python production is fine as a UX. Why not? Why go overboard when you don't need it?
Well, there was a company who were acquired by Snowflake called Streamlit, who just do Python UXs for data applications.
Similar to Gradle, right?
Yeah, but 900 million. Was it $900 million? I don't know. You can use, and the great thing about Streamlit is it's free. They have a cloud tier that's free, so you can actually deploy your UX written in Python, and it runs for free.
But I think if you go into this whole idea now, I mean, I think there is let's call it the chasm between. We have come quite a far way with with BI. I was going to say, and we're doing our dashboards and reporting on our descriptive, all the stuff that you find in a normal business, right? And people think there's a huge hurdle in terms of the modern stack we need in order to do something cool with AI.
The modern data stack, you mean?
The modern data stack, and we need to re-platform for 5 years in order to be compliant with this. Yeah. And that's not the way, of course. So finding these ways to sort of learn the fundamentals, and then, of course, how long is a piece of string?
I mean, look, this is something dear to my heart and something that I'm working on right now, which is this chasm between the modern data stack, which is a SQL-based world, where we have Snowflake.
Is that the modern data stack?
The modern data stack is a data warehouse that scales out.
So is this modern? Is this modern?
Well, I mean, it's if I can get a little bit technical with you, it separates compute from storage, and it's able to scale out a lot better than it did, let's say, 10 years ago. So they have solved some of the challenges related to scale and being able to, process large volumes of data in a short amount of time. The price, of course, you pay for it is quite high. But I think for data scientists, if the data in the enterprise is now primarily located in data warehouses and, it's accessible via SQL, do data scientists speak the language of SQL? I think they speak the language of Python. And that's the chasm for me, is how do you go from the Python world where we have all these libraries and frameworks, and we want to get the data from the modern data stack. We want to train our models. We want to be able to, create features. We want to be able to run inference pipelines. So
that was my joke. How can you define a modern data stack that only runs SQL? Obviously, it's incomplete.
It's not your incomplete for sure. Okay, I added some of my questions here now, and one of them I may disagree a bit about, what putting in production means or the consequences of that. But let's speak a bit more about that shortly, I think. Yeah, there's so many good questions popping up already. And also the data warehouse and data lakes and whatnot. I think that's another interesting topic that I'm sure you can speak at length about. But before we do that, I'd just like to welcome you here, Jim Dowling. It's great to have you here.
Thanks,
We've known each other.
Thanks, Henrik.
We've known each other for a long time, and I think I must say that every time I met you, I've been really impressed. Not only about that you have really deep and broad technical depth, but something that really impressed me more is the ability for you to communicate. I mean, I think very few people are skilled at communicating, and I think it does, of course, require, if you want to be able to communicate something efficiently, you need to have really deep technical understanding of it, but it's not sufficient. You also need the ability to communicate in a non-technical way that people can understand and do that in a concise way. And I think you do that more than most people I've ever seen, I must say. You can speak in metaphors. No, but it's really true. I really mean it.
Now you need to prove it.
Well, I've been a professor like for quite a while. I mean, that's part of the training, isn't it?
It is. I mean,
no, but not everybody still is doing it well. I fully agree with you, Anders. It's an art.
It's really few people that can speak about complicated topics in an easy to understand way, and use metaphors and speak about things in non-technical terms and still be able to explain the core concepts properly.
Without,
Is this a challenge for today?
No,
it is.
It is.
It became a challenge when you asked it. When you
I'm
asked
on
it,
the spot. Okay. No.
It's just my opinion, but you should really...
You're too kind.
No, it's really true, I think. And of course, you have an awesome Swedish company that is doing something very important for our society, I think. So I'm sure this will be a very, very interesting discussion. But with that, let's start with a brief, at least, background about you. Who is really Jim Dowling? How would you describe yourself? Who is Jim Dowling?
I'm not sure I'm that interesting. I grew up in Dublin, Ireland, and I went to university there, and I went to my PhD in the same university. Lived in Germany for a couple of years.
How many years ago was that?
Oh my God! I thought about it on the way down here, and it freaked me out. Right?
Question: Who of us did the PhD earliest?
No, I'll tell you what. Who started in university first? I'll tell you. 30 years ago, I started my bachelor's.
Bachelor's, yeah.
I just before in October it'll be 30 years.
Really? So
92 I started. I was just 18, just turned 18. So I'll be 48 this month. It's kind of crazy, but
I think I'm not saying my age.
No, exactly. I'd say my age. In Sweden, you can look it up. You can find out my age.
I started my bachelor's in '94, but I think we are behind
the same
nest
generation.
Yes, we're the same generation, I think. Yeah.
Oh, now you're too kind to Anders all of a sudden.
No, but I did my PhD in Dublin as well, and then I just met this Swedish girl, and then I was like,
"That's how we get talent in Sweden."
And the thing was, I was a lecturer at Trinity College Dublin, so I kind of made it. I had this nice job in the city I grew up in as a tenure.
In a nice university.
Yeah, great university too, and really, in my research group back there, my supervisor, he was one of the co-founders and the first CTO of a company called Iona Technologies. Yeah. So I lived through the boom in '99. His company were worth billions. I think it was maybe 3, 4, or 5 billion at the peak. Really? They ended up crashing, of course, and selling for 250 million. But that's another day's work. But there was all this excitement, and he had a huge number of PhD students. There were all these startups jumping out left, right, and center. And then when I came to Sweden, I worked at MySQL for a couple of years, and then I went back into research.
And that was KTH then, directly?
No, I went to Rice actually. So it was
Rice,
called SIX at the time.
Yes.
And so I came here in 2005, and 2007 I started at SIX.
You were at SIX.
Yeah.
Same time as Lars Albertsson and
Lale was
there.
Lale was there for not very long, actually. Funnily enough, he was there for I think maybe 6 months, and then he went. He got itchy feet to get into industry. But I clicked well with Lale, and the other person, of course, who's very well known is Ali Godsi, who he was kind of peer in mine. Because he got his PhD about a year after me. We were in the same group, so. We worked together for maybe 5 years there, I think.
No, but there's a few people that we have on the pod who's been through the SIX, that part of the industry. That's quite interesting. A lot of really smart people.
A lot of interesting things happen out there. Even just our research group, of course, Ali Godsi went to co-found Databricks, but even Apache Flink, which if you remember Apache Flink, so Paris Carboni, who's still there in KTH and Rice, he was the guy who came up with the first version of the streaming architecture of Flink. Now Flink existed, and the TU Berlin people were working on it. Volker Merkel's group came up with Flink, but
we had some collaboration at that time as well with Spotify and SIX, right? So,
and actually, Flink. We helped get Flink in there. And the first thing I noticed when it went in there was that Flink would only run as a username called Flink in Unix. And we're like, I'm an old systems guy. I was like banging my head off, going, "Oh my God, 'Cause I was trying to build this file system at the time, and I was thinking about things like Kerberos integration and so on, and they were like, oh, the thing only runs. And anyway, they're database people, not systems people at the time, and they had to learn the systems thing, I guess. But yeah, so a lot of cool stuff has come out of that group. You know, you've had like, you know, the Databricks and the Flink, and then we came out of the group as well. And Paris is doing really interesting stuff there these days, you know. And
is he still at the Rice, or? No?
Yeah, he's part-time. He's KTH, so he's now got a position at KTH. He's a you know, associate or assistant lecturer, I think. So you know, we're colleagues there, and yeah, but he's doing some really good stuff there. So.
But it's a little bit like in football or soccer. We had a really good generation. The boys born in '75, they were kicking ass in '89.
But I tell you, a university background or a research background like Rice, I've seen, you know, Databricks came from that background, the Flink, you know, the platforms that really can, you know, break the boundaries and come out with something new. Like my old research group in Trinity College, they went and found Iona Technologies. It was the first object-based middleware, and the whole group left, except my supervisor. He stayed on, and then he was head of the group, and you know, which is kind of cool as well. But you see that whole research groups leave, and we had another one called Havoc in Trinity, and the whole group left to do the company, you know, and to some extent we did that with our company. A whole bunch of us left, you know, 10 of us.
Do we need more or less of that in Europe compared to America?
I think you know the answer, don't you? Yes. We need more, of course.
We need more.
We need way more, yeah.
I think we, just for the listeners, should explain a bit what Databricks and Flink is. Do you want to
yeah, I can have a go at that. So, you know, Databricks are a company. So Ali Godsi he grew up in Stockholm, and he did a postdoc at Berkeley, and he worked with some people there. So what they were doing was larger volumes of data were being collected by these internet companies. You know, we had this growth in data storage, and there was good platforms for storing large volumes of data, but not very good platforms for processing it. So we had some platforms came out like Hadoop it worked, but it wasn't. Nobody loved it. Everyone hated using it, and it was challenging and it was slow. And Matej Zaharia, who works at Databricks now, co-founded Databricks with Ali, he was the guy who came up with the framework.
as well, right? Or?
Yeah, but I mean, Spark is ultimately Matej's, his personal project at the beginning. Now, Patrick and those guys obviously helped, you know, lift it up, but he developed this framework in Scala, which would process large volumes of data in parallel very fast. So if you were collecting at the time, you know, tens of terabytes of data, and you're not going to put it in a database like Oracle and spend millions of dollars, he said, look, here's something open source. Just put it on commodity hardware, so cheap servers, store tens of terabytes or even petabytes of data, and you can process it all in parallel. And now you can do things like track people on the internet. You can do things like... Is
that a good example to start with?
Well, you know, you can do...
The first use cases.
No, but I mean, you know, recommender systems and being able to understand. So this whole thing of analytics that has grown and exploded in the last 10 years kind of came through this ability to process large volumes of data.
And also, I mean, I think we should mention that Hadoop, of course, was a big thing, open sourcing the Google big data MapReduce kind of movement that they did back in 2005 or something.
Yeah. Yeah,
but, Hadoop, and that was, you know, so many people were hitting the head in the wall working with Hadoop, right? And
well, I mean, it was based on this functional programming paradigm of a map function and a reduce function. And I remember Volker Merkel, who founded the Flink project, came in and said, yeah, this is a second order function, right? You know, I'm professor going, what does he mean? You know, like, and so, you know, you're trying to get people to use this platform with second order functions, and it's kind of, even good programmers are really finding it difficult. So Matej had to introduce a new programming paradigm and a new abstraction. At the time, now it's called a data frame, right? But at the time it was called an RDD, you know, a resilient distributed data set.
And now it's called data sets, I think.
Yeah, they're just called data frames, I think now.
I think data sets now. But
in Scala, the typed ones are data sets, and then the untyped ones in Python is data frames.
I can see some combat coming on today. I love it.
I think actually it's, okay. Let's not go there, but still.
Yeah, but Flink came out actually just around the same time, doing the same thing as Spark, but it came from Europe, not from Berkeley. And they didn't get... $80 million in funding to kick it off. They had to fight for like 5. So just that differential in, you know, the investment in the States that they get and the access to capital meant that Spark grew really fast, and Flink had to find a niche because they weren't going to be the main open source, you know, big data processing platform. So they found a niche which was related to very low latency, or what we call streaming data. So if, for example, everyone knows TikTok, right? So why is TikTok better than YouTube, because as you're scrolling, it's adapting. Its recommendation algorithm is adapting to I'm going to stay a bit longer on the sports. Okay, I'll show a bit more sports, but it's doing that within a few seconds. So how does it do it? Well, you have to process huge volumes of data on many, many servers, and it has to be done in seconds, because that's what TikTok's doing. TikTok's not actually updating the model. It's not retraining the model. It's just updating the data. What have you looked at recently? And Flink does that. Flink is the system that powers that.
Stream processing instead of batch processing.
Exactly. Stream processing. So it's processing the data as it flows through the system. And the batch ones just say, okay, pile up the data. We'll do a big chunk of it.
And analyze it later.
Yeah, it's computationally efficient. You just use the compute all at once. The streaming ones are kind of, it's a lot more work to operate them, but the really high value that you can create in businesses like TikTok, you need to have that little extra, the streaming kind of, live updates. And then I think Andrei Karpathy called TikTok, he called it digital crack cocaine. Yeah, he did. He wrote that on Twitter. It's like digital crack.
Oh, nice.
I think when he quit left, I don't know what happened there, but when he left Tesla, he probably had time to start using TikTok, and then discovered, wow, what have I missed all these years?
Are you guys using TikTok?
No. My kid, my oldest boy, he's 12, Eddie, if he's there. Yeah, he'll be 13 soon. He has 30,000 followers.
Really?
Well, I have been fighting like hell to get a few followers on Twitter, and he's like 30,000.
What does he publish then? Or let's see.
He's bilingual, so obviously he's Swedish, but he speaks English as well. So he tends to do them in English, and I think there's these subcultures on TikTok, and one of them is I don't remember the term for it, but it's when you make fun of someone. So there's someone called
memes.
Charlie.
Charlie.
No, not memes. It's I don't remember the term, but slander. They call it slander. So the kids, you get Swedish kids going, oh, that's slander, and you're going like, I thought slander was when
like
you
roasting or
yeah, kind of like roasting, but they call it slander. But so there's someone called Charlie who apparently is huge in the YouTube TikTok world. I don't know.
In exactly this niche.
She's famous for being famous, So he just made fun of her, and then he got like, I don't know, 500,000. He went around the world. I don't know.
That's crazy fun.
Okay, so let's just get back to a bit. The Databricks got started. I mean, they got started from the Spark Foundation as well, or the Spark framework.
Yep.
That was like changing or revolutionizing, how you do big data in some way, getting away from the traditional Hadoop world. And then they built some kind of commercial company around that, and that became Databricks, right?
Yeah. And they had some great foresight there, So I remember meeting Ted Dunning, he was behind a company in the Hadoop space called Mapor, and they were the giants, and Databricks were the small kids. And Databricks didn't want to work with customers. They said, no, we're going to just build this cloud thing. And he was laughing at them, going, you have to work with customers. This is so naive. But they made some really great strategic decisions early. They said, we're only going to go on the cloud, and we're going to try and dominate that space. And they had the capital to make that long-term bet. And it took them a long time. Like, Databricks didn't work for the first few years, really,
I remember.
And
do you think that is a good strategy in general to not use customers from the start?
No, it wasn't. I think they didn't want. They just wanted to focus on building the product, right? Because there was some interest in.
Is that a good approach in general?
I think if you
build
can,
a startup,
it depends on your time horizon, right? So if you have if you think that a complete product that I can sell and support, and it's not going to kill me, is not there yet. I need to, because there's a lot of things I need to add. A lot of customers will ask for this, and and if I support customers early, I think actually a lot of the Hadoop providers, particularly Hortonworks, suffered in that way. This isn't the old, I say old, it's not even 10 years ago, 6 or 7 years ago, but they took on a huge number of customers, and the platform wasn't mature. And then when they had to upgrade them, it was the most painful. They had thousands of people working there, and Databricks could keep a smaller number of engineers focused on building the platform for the cloud. And I think they didn't want too many customers too early, because they knew that the product wasn't ready.
So now we're moving from MVP to MLP, minimum lovable product.
I think they were loved from the beginning, even before it didn't work. That was the magic of it, So
I mean, cool. I mean, it's one of the awesome products that we have out there, I think, today. And so many Swedish companies and other companies around the world is using Databricks today. And
but how would you? Maybe this is too early, but I think it's interesting. How would we define the Databricks value proposition and positioning anno 2022 versus where they came from? I think they're finding
Oh,
their
yeah,
space now, and
It's changed.
Now
I
is
mean,
it the
now it's a data warehouse company.
now it is a data warehouse company, or is it the
No, it's a data warehouse company. No, well, they would say it's data warehouse plus AI.
They would, and they would
I
argue.
think they would say a data lakehouse company.
Data
though.
lake
You're
house.
correct, lakehouse. So
This is
it's
data lake
beyond
house.
the warehouse. It's now it's more scalable than the warehouse. It's
Yeah,
a data
and-
lake, but behaves like a warehouse.
But do you say that? I mean, do you believe in a lake house kind of mentality or idea of combining warehouse with data lakes?
I mean, it was a smart marketing move. The first thing they had to do was get a paper in a top-tier conference, which they did, and then you can call it lakehouse. So you need to have that credibility. And if they didn't,
But you don't subscribe to the idea of combining the two and have a single system for both
no, I think
data lake and data warehouse purposes?
I agree that most data should be structured or tabular data, right? So this idea that was commonplace in when big data took off, to just dump your data there without any structure on it, is probably a bad idea. Right, and I think,
But
and
if you take unstructured data, then
Yeah.
like images, text, audio, whatnot.
yeah, I mean, there's a huge explosion now in unstructured data, particularly documentation, right? So, you have call centers that are being transcribed. You have anything you talk to someone anywhere now, it's being transcribed. Petabytes of that data flying around. If you take, we work with customers who do, for example, we have a couple of customers in the employment space. So nowadays, when you upload your CV, it's getting parsed and there's NLP processing it, and you're doing, it's matching them to employers' requirements using embeddings and stuff like that. So all that data is being stored somewhere, and it's not tabular data, right? And we have seen, what's interesting, however, is like, this is where I think it's maybe not clear for people outside the industry, is image data, which is the foundation for these deep learning system companies like Tesla, who do self-driving cars and so on. That's kind of bifurcated or moved away from the tabular data that we see in the enterprise. So you're seeing platforms that are specialized on image data for labeling image data, for managing image data. It's like you said, Anders, it's the data lake, right? You're not going to put that data into a data lake house. It's just...
Or a lake house, yes, but not a data warehouse.
Well, I wouldn't put it in a lake house either, because it's going to cost you a fortune. It's like if you dump it into S3, it's going to cost you...
But S3 could be part of the lake house.
S3 is the bottom layer, of course. Yeah, sure. But I mean, the idea of a lake house is still structured data primarily.
I would disagree on that, but okay.
Yeah, I mean, look, I read the marketing from Snowflake and Databricks, and they say store all your data here, blah blah. But like for me, if you're going to call it house or something, there's got to be structure there. Otherwise,
structure
it's just
in like a schema, yeah. But
structure in a schema, yeah.
If everything is based on some kind of storage solution like S3, and then you can use some kind of schema on top of that includes both unstructured and structured data, and then you can use a simple API on top of it, like Spark's API or whatnot. And then you don't have to have two different systems, one for the structured data, one for the unstructured data. Wouldn't that be a benefit?
But I don't think it makes any sense, right? Because unstructured data is by nature very different depending on the type of data.
But
so
if you can abstract that away, wouldn't that be beneficial to have the same system for both?
Let's take an example. I'd say, because we worked a bit with self-driving cars, right? Yeah. So you have images that are taken, you have videos, right? There are files. That's ultimately how they're stored. So they're stored as files on an object store, and you have metadata to describe those files. Yeah. Okay. Now, what does the lakehouse give you as value added here, right? Does it give you a schema for finding that? Is it going to be tabular data? Can I do free text search for it? Because if you think about how people store images, you want to be able to search for them. So I'll give you an example, right? If I'm a car company and I've got trillions of images, and I've found some case where the car is not driving properly, right? There's been a scene has happened and it's misinterpreted, right? So what I might want to do is find a similar scene in one of the images and see what's happened, right? How do I find that in the lakehouse? I don't think you can. I think what you need to have for something like that is you're going to have all the annotations of all of these images, and you need to be able to search for them. And you're probably going to use, what type of search will you use? Well, there's different types. You can use embeddings to look for similar images. You can use tags to say what's in there. The image that you have here, you can say, well, find other images that have similar tags. But I don't think that by itself is something a lakehouse gives you. I think that's something you build yourself.
I have to go a bit technical here.
Okay.
But let's say that you have some kind of storage on top of some object store. Some S3 similar thing. You use some kind of data storage or format like Parquet or something, which is columnar kind of storage. Which you could have a column which is images potentially, but then you have other columns that are potentially structured data. Wouldn't it be beneficial to be able to store that if it is as efficient, more or less, in the same type of system, in the same type of architecture, in the same type of hardware that you have, without having to have two different systems that you have to communicate between and also manage?
So we get this question quite a lot because we build a feature store and people say, can I put images in your feature store?
Yeah.
And the problem is that the tooling built around images. So imagine images have file formats too, right? It's not just PNG, right? If you go to the hospitals, they've got DICOM and they've all these other ones. There's so much tooling built around those file formats.
Yeah.
You know, how do I find a certain offset? If you have a video, the video file format has there's tooling around that. So if I take that file and dump it into a Parquet column, how can I process it? My tooling won't work,
Why not?
Because it's in a Parquet file. Now what I have to do is
read it up quickly.
Yeah, but you have to. What you have to do is your tooling is native. It only understands its file format. So now you're going to have to build a wrapper around your Parquet files. First, you have to find them, right? Because in Parquet files, you have to know, where is this image? Where is this image amongst? Because if I have a Parquet file or folder, it's a folder really with lots of files inside it. Yeah. I have to find metadata first. So if we take the Lakehouse Delta Lake, that metadata is just another file inside that directory.
Sure.
And you're reading up that file to go look for another file somewhere else, and it's going to take a long time. And then you're going to have to do is you're going to have another layer which is going to interpret the contents of the file. It's not going to be able to, if I'm able to, for example, index the offset in the file and do it efficiently because there's a data structure inside this file format, you won't be able to interpret that. So it's just like it's not being done right.
But
it's
the alternative is to store it somewhere else, right?
Well, the alternative is specialized software for managing all these different file formats.
But storage
indexing. No, but indexing, like what we talked about earlier. So if I have an image of the car companies finds very difficult to interpret, I want to find similar images. I want to find it with similar amount of percentage of darkness in the image. I want to find one that also has 3 strollers in the image at the same time, or that has an overhead thing. You're tagging them. You're building a huge amount of metadata and rich metadata around it, and how you need to search it. For me, that's not what a lakehouse does. Like a lakehouse for me is really, and maybe we need to define what a lakehouse is, but really for me it's tabular data and you can put stuff in there. But
let me try something here, because I'm hearing a discussion between a more central monolithic understanding of how we understand the central data lake, and now we want to have the one system that rules them all, versus the more modular domain-driven architecture, now spearheaded by the data mesh architectural paradigm, and where we basically move more closer to fit for purpose design patterns and therefore technology stack for the purpose at hand, and then having abstraction layers so we can create interoperability between data products in a mesh when we need that. So what I'm hearing now is that you are saying, well, kind of like fit for purpose, and then that becomes more modular. So you don't become, we're not going to force everything into a central data lakehouse. This is just an evolution of the central story that is now trying to have a very different design pattern working with an old tabular design pattern. And why not keep...
At some level, but I'm talking at a lower level, and I'll just try and explain the lower level, because I don't think it's too hard to explain, okay? We've had huge growth in data volumes in the last 20, 30 years, right? So 20, 30 years ago, we had Oracle. You dumped everything in Oracle, right? And maybe you put stuff in NFS. But when the data volumes increased, there was an opportunity for us to have different ways to store data, graph databases. So we've got Neo4j from Sweden, the most successful graph database company in the world. They didn't exist more than 12 years ago, did they? I think they were founded 12, 13 years ago, maybe 15, 14 years ago. But they became a viable company because the volumes of data created that fits well into a graph format has increased. Because if the amount of data is now 100 times what we had 20 years ago, there is huge room for specialized storage of all of those data. Because there is variety, exactly. And I don't think the lakehouse, as a pattern, has that variety. It would be my take on it. And there's just too much heterogeneity. Now, I think more and more data is being stored in the lakehouse. I think more and more enterprise data. I think everything is getting trying to be shoehorned in there, which is fine because it's great to have a single place. But it's shoehorned.
That's the point that you're trying.
No,
to
I don't think so. Tabular data will fit in the lakehouse.
Yeah, but when we're talking about the variety, sort of data that is not really tabular in any form or has not a really tabular use case.
Yeah, I wouldn't be putting videos or voice transcripts from my a customer service place in the lakehouse, but that's just me, maybe.
But maybe it could be also that you have a very clear use case for the how you're sorting and you're doing video with the normal use cases you do, and then you figure something out. I want to now store something out of this that I can then now fit as an index in the tabular format next to other data. So, but then that's something else, right? Then we have refined something, or we have created something new.
Yeah, I mean, I don't know. I mean, I think just the volumes of data are increasing, and we're seeing increasing specialization. There's more and more databases. There's 50, 100 databases out there now that are big, and they're all doing specialized this, specialized that,
I think this is a really interesting question. And I know you have RonDB, etc., based on MySQL that you're using for the feature store, but I think we should continue that discussion shortly. But it's funny.
We love rabbit holes, by the way. You realize that now.
I think still there is a big merit to lakehouse architecture.
I'm not saying 40. What are they? 40, 50 billion?
Yeah.
Snowflake 80 billion.
It seems to work really well for them.
It seems to do very. I mean, obviously they're doing something right.
Yeah. Cool. Okay, that was another rabbit hole. But we spoke about Databricks. We spoke about how they're working with Lakehouse. They have some service on top of, or cloud service, I guess, on top of Spark as well. We didn't really mention Flink, but if we should speak about that really briefly, how would you describe Flink potentially? And I guess compare it to Spark.
Well, I think there's two stories at Flink. Flink is a massively successful open source project, an Apache funded project, and it's now the dominant global platform for building what we call streaming applications. So applications. Really? Well, I mean, it's the biggest, right? It's the most widely used.
Compared to Dataflow or even Spark, that has more proper streaming-based solutions as well?
Tencent, Alibaba, all the big, in China when they have this, what is it, that day in November, I don't remember, Singles Day or something, they have billions of transactions per day and it's all run on Flink, like Uber run all their streaming stuff. It's a massively successful streaming platform.
Good points.
But they, I think the people who developed it from TU Berlin, so we had a project with
Stephen,
them.
right?
Yeah, Stefan knew, and we had a project with them back in the day.
They're really good. I mean, they came from a database community as well.
It's a database community, so it's Volker Merkel's group, and they did a really great job. And I think, honestly, it's a little bit of a tragedy for Europe. That is, they were the leading big data company from Europe, Ververica, who built this out. And, who do you blame? I mean, it's like maybe they should have been a bit more commercial a bit earlier. Yeah. But on the other hand, they weren't getting the capital that people were getting in the States. So in the end, we sold the world's best streaming application for 90-something million euros, I think.
Really? It was that low?
I mean, if that had been a value company, it would have been at least 20, 30, 50.
Who bought them again?
Alibaba, wasn't it, I think, or one of the Chinese. Yeah, I think it was Alibaba.
Yeah. That's really
and like from geopolitical point of view, right? If you're if we see the States are now saying you're not allowed to buy NVIDIA chips, right? So imagine the States said, "Oh, you're not allowed to use Databricks," and the Chinese had built all of their Alibaba on Databricks, but they didn't. They're smart. They got in Flink. Now they build it on Flink. It's theirs. They own it. We don't own it in Europe. We didn't have a cloud. Europe doesn't even have a cloud.
We're getting into so many of our favorite.
Yeah. So anyway, that's my take on Flink. But I think it's a great project and it's been massively successful. I would have loved to seen a great European company come out of it to lead. It's not going to happen. And then, all the founders have left. They all just gone.
It's a brain from
let's
Europe.
a little bit park this question now. And I think this is one of our most important questions we can talk about. How do we create a cloud powerhouse in Europe? How do we not fuck up again? We have
done a number of very successful Swedish and European companies as well.
But still. I'm with Jim here on this fundamental cloud infra fundamental stuff that is sort of not is coming from Europe. And if you we can't make that happen. Actually, you had it, but you didn't invest in it. You didn't do what was supposed to happen. If you wanted to kept it, you didn't. So how can we not make that mistake again? I think there's a couple of core questions to unpack here at some point today. Is that cool? I love it.
I'll add it to the list for sure. We always have this kind of US versus China versus Europe.
The AI divide,
Swedish
kind of,
and,
data, the whole divide here. How can we catch up?
Cool. Short story about Flink there as well. Okay, so should we just wrap up a bit about your background as well? I'd love to hear a bit more how you got started with logical clocks as well.
Well, we're Hopsworks now. We changed our name. Yeah.
Are you not called?
No, we changed our name. We got Jim Duffy came in from MongoDB, and MongoDB is a very a well-known database company. And the company were called 10gen, and he said every time we went to a customer, he said, "Well, why are 10gen selling MongoDB? Who are you?" And then the 5 minutes of the conversation is wasted. Yeah. So he came into us, and we were Logical Clocks selling Hopsworks, and he said, "What's this?"
Yeah. It's weird. Yeah.
So now we're officially called. We changed the name this year to Hopsworks.
Okay.
Yeah.
I didn't know that.
So Logical Clocks is a cool name, of course. That's from distributed systems. It's a building block for distributed systems. Yeah. I even have a photo of Leslie Lamport with a little Hops logo. So he's the father of distributed systems. So
awesome.
That was kind of cool.
Okay, but before that, you actually did some research, right, in Rice, OR6, and KTH, and that led into this company somehow.
Yeah, the company started. So when I had this background where everyone was doing startups, and I kind of I thought always I'd like to do one, but if I'm going to do it, it's going to be on something that I build, right? Not just jump on the startup. So we started a project in, I think it was a long time ago, 2012. And I'd worked at MySQL, and we had this fantastic database, NDB, that Mikael Ronström had developed, and it was a distributed in-memory database. And I knew that a lot of distributed system software could be rebuilt to be more efficient with a distributed this distributed database. So distribution means you run on many servers, and it means you can store more data and be faster. Think of it as being a bigger brain. Right, so I can have a small brain on one server, I have a big brain on a lot of server. So, and also it can be, and then if you get failure, so if that brain fails and it's on one server, the whole thing goes down. So, so that's
speaking about communication skills.
Yeah. But anyway, so that database, when you turn on your phone, most people in the world are using that database right now on your phone, and it's built here in Stockholm, and the company, it was Ericsson who built it originally, and then MySQL bought it up when Ericsson had the crash in 2003, and it's an open source database, and as you know, when MySQL were bought up by Sun Microsystems and Oracle, a lot of people left and they forked their databases, and we forked that database, the in-memory distributed database. But back in 2012, we built this open source file system around RonDB, and we forked off the Hadoop file system to work with RonDB, and that was a research project. And the first go, we had 6 months just to see if this thing would work, and it was 100 times slower than the Hadoop file system, but it kind of worked, right? And we're like, yeah, okay, this will. Now we need to optimize, So don't premature optimize.
And help me here. What is the main problem? Why this is useful, or why you need to go in this direction? If you explain it.
Yeah. Okay. Why is it useful? Okay. If you want to jump all the way ahead to today. Right. The work we did back then is with this distributed metadata layer. That's the enabling technology why we have the only serverless feature store for machine learning. So the only data layer for machine learning, we're serverless.
So basically, when you did that research project, what were you trying to test out, and why were you trying to test it out at that point in time?
Well, at the time, we wanted to build the world's fastest file system, and we actually got there. We won the IEEE Scale Prize in 2017. It took a long time, and we got, some really nice papers out of it.
So here the fundamental idea.
Okay, I'll just get back to the problem. Okay, so we had a research project called Biobank Cloud, and we're working with Karolinska and many others trying to store data in this new file system we built. And they said to us, yeah, it's great to have data in here, but you have to have a new security model that doesn't exist anywhere else. And the security model has to be that when someone is, it didn't exist in any other file system that we knew of. And it basically said, okay, when you're working on your data in this platform, you can have access to it into this project, or think of it as being a research project, or in medical world, you might be working on, say, cancer for cervix. And then you also have another project where you're working on, prostate cancer. Now, when you're working on the prostate cancer, you shouldn't be able to read the data from the other one, right? You should take away your privileges to do that while you're working on prostate. And when you're working on the cervix one, you should take away your privileges to work in the other one. And in the security world, this is a quite a complex area. It's called dynamic role-based access control. So you're able to change the roles that you have on the fly. And none of the kind of scalable file systems did this. It's also called attribute-based access control, but you don't get any high-performance systems that have this. So we spent a long time trying to think, how the hell can we do this? You can't do it. No one does it. And then we kind of said, okay, we can do it. Okay. So we built something, we call it project-based multi-tenancy. I don't think anybody really understood what it was, honestly. And here's
that's the core problem that you're starting out. That's meant you need to code somewhere else or go something.
Yeah. Okay. Well, if we go back to the question of what does the bigger brain buy you, right?
Yeah.
Snowflake, right? Mm-hmm. Snowflake are kind of the darlings of data and have been for a couple of years. And one of the things that people think about Snowflake is amazing is they have this data ecosystem where you can get a data set. So give me that data set. Press a button and you've got it. You can have a database and you can say, clone it, press a button, you've cloned it. And you go, wow, zero time clone. This is amazing. How does this work? Well, if you look at the earlier Snowflake talks before they became corporate, they said, well, we're building on a distributed in-memory metadata layer that scales out on the database called Foundation DB. So they have these huge Foundation DB clusters which Snowflake works on. So some of the key features of Snowflake that make it trivial to share data between to buy and sell data, and also to be able to have this marketplace of data is built on this capability. So without it, they couldn't do it. And Databricks don't have it yet.
So, really. So here we have an architecture which is distributed. So if you truly understand what you can do with that, it opens up an array of new use cases or applications or problems you're solving with it that is otherwise quite hard to solve.
Yeah, but they're mostly at scale, so there's only a certain amount of people who have that scale requirement. But I think, there's really cool, I saw this week in Hacker News, there was a blog post came out about a number of researchers, maybe 20 from the States, from MIT, Stanford and others, who are working on building an operating system around this principle. So the operating system is based on a distributed database at the bottom, and then you build the compute on top of that, and then the resource scheduling and so on top of it. So it's kind of in the same thinking, right? That we shouldn't just have everything on one server. We should be able to go from having a brain on one server, because Moore's law has been reached. At some level, you're not getting double the number of cores on your machine every year, but you can add more servers. And we see this, of course, in deep learning, right? At some stage, maybe 5 or 6 years ago, the performance improvements in deep learning just went to distributed. So you chuck more GPUs on it, and then you can train models faster and bigger models.
That was my ignorant question here. How does this relate to the whole CPU, GPU parallel processing versus not? Like, is it completely something else?
No, I think like for your average developer and for your average person working in data, I think the biggest change in the last 10 years has been that it's much easier to have larger volumes of data and do your work with it, right? So you can have more CPUs, you can have more GPUs, and particularly Snowflake and Databricks and those have made it much easier for you to push in huge volumes of data and process it. Now, it has been mostly SQL, and then we have Spark, of course, and Flink, but they're a bit more challenging for many developers. But that's been a change, and that makes it easier for people to do things that they found difficult years ago.
Just getting back to the original question here about how did you get started with Hopsworks?
Yeah,
and you started to.
Sorry, we went off on the tangent.
We love
that
it.
was a
I
bit
love
crazy,
it.
yeah.
And you started to work and did research about finding the fastest file system, and it should be. I think also at that point it shouldn't be a single point failure as normal. I guess the alternative was HDFS at that time.
Yeah, right? so HDFS had this brain running on one server, so the metadata, right? They still have it actually, right? So, and
this was called HopsFS.
We call it HopsFS. Yeah, it's still there. It's still powering the platform. So the difference now is that it doesn't store the data locally in the cloud. It stores in S3, so you don't pay.
Right.
So that's another interesting anecdote. Like, so the cloud vendors will not let you have a file system that can compete with them economically. You just can't. I mean, because S3 is just cheaper. Like, if you tried to build a file system on virtual machines, it's just not going to work. Economically, but so we rewrote HopsFS.
So you rewrote it
for economic reasons, not for
economic reasons.
Yeah.
Basically, it has to have an S3 bucket somewhere.
Yeah, the data has to be stored in S3 buckets. Otherwise, it's not economically viable or feasible. But in any case, so we had then this multi-tenancy part on top of the file system. We said, let's just add some layers. Right? We can add some layers of compute. We can add Spark. We can add a user interface, and we started doing it as part of that project, and that went really well. And I think around 2016, I wanted to keep people in the company. So I said, let's form a company. I had no idea to start it, but I just wanted to keep the researchers in who maybe were doing masters but didn't have the ambitions to stay in a PhD, but to keep them focused.
I need to have another story here, because otherwise they're walking out through that door to continue their studies or whatever.
Yeah, I know, because not everyone who maybe works for you for 6 months on a project is going to want to stay for 4 years to do a file system, and they're going to think, but they can see this potential, and they can see that a company could do something. So let's do a company. But then we stayed in research for a couple more years. It was only September 4 years ago that we actually got venture capital.
So you were bootstrapping at that time.
Yeah, I mean, look, it's all open source.
How are you financing these guys?
It's all open source. Well, we had a lot of research projects.
All right.
And we were building this thing, right? So the research projects were about, how do we help people with large volumes of data, and then
so
the security
research
challenges.
funding the first couple of years in this sense.
Yeah, and it's brilliant. That's in Europe.
We should probably speak about the venture capital kind of journey as well at some point, because I think it's an interesting one, and also speak a bit about how the startup company and venture capital scene in Sweden and Europe is compared to US, etc. But okay, so you built, just trying to close the story a bit about how the company got started. So you had Hops FS, and you added more and more layers on top of it. Do you have like a mission statement or something that what Hopsworks is really trying to do?
I mean, what we're trying to do now is we're trying to manage data for AI. And in particular, we're trying to manage real-time data as well for AI. So that's kind of what we're doing. If you've got data and that's feeding your AI systems for training, for serving, for inference, batch inference, online inference, we want to manage that data and help you manage that data. That's kind of what we're trying to do. So everything from curation to accessing the data to and so on.
And before I think we should move into the feature store kind of story, because I know that it's one of the USPs that you have. But before that, it's also, I guess, that you're trying to do something else. If you want, as a company, to start using AI today or manage data in some way, there is a lot of open source out there. There's a lot of research projects and GitHub repos out there that you can start using. But there is some problem for that. Or how would you say, what are you doing, and skip the feature store for now, to try to help companies get started using data for AI?
That's a great question. I mean, we're a company first and foremost, so, we're trying to make customers and so on. But we do have another initiative right now. If you're curious, serverless ML. If you just go serverless-ml.org, I'm going to run a course in a couple of weeks, which is how to build serverless machine learning systems. So if you've done a course in machine learning where you've taken a static data set, and you've tried to train a model, maybe in a notebook, and you've evaluated the model and said, oh, look, it performs very, very well on this test data set, this holdout data. I can see that the model will work on new data, not just on the data it was trained on. Brilliant, you're happy. But the next step after that really is to build a service that will use that model to make intelligent decisions. So maybe it's going to predict something. So I'm calling them prediction services, for want of a better term. I don't know if it's a great term, but it's a service that's using models to make predictions or decisions.
I think this sounds really awesome, but help me here. What's the context in terms of what your problem you're solving? How is that fitting? Like, let's say I'm in a big enterprise. I'm in a telco, and I've chosen to go AWS Lambda serverless. All this. Tell me the story here. How does this fit into sort of what you can kind of expect, or actually what you would hope to see to have a perfect fit when you go to this telco?
This one is slightly different. So I'm not trying to get somebody who's using serverless in AWS and so on. It's really for Python developers who've started the machine learning journey. Maybe they have a software engineering background, maybe not. They can write Python code, but what they'd like to build is a prediction service around that model that they've trained. So a user interface in Python, and then pipelines to get new data in Python. At the start, we talked a bit about surfing. That was one example I gave, right? So that's a serverless machine learning service. And to have a serverless machine learning service, a prediction service, let's call it, not just a model, but a prediction service, you need three things. You need compute, you need storage of data, and you need a user interface. And okay, maybe you're going to make your service available over an API, and you don't need a user interface because some other applications getting it, but let's not get into the details. If I'm going to, things I'd like to do in this course, we have electricity prices you can scrape from the internet. It's live data coming in. Who wouldn't like to know the electricity price next week?
Can I have this?
Yeah, and do you know what I found? Another really cool one is air quality around Stockholm. I live in Liljeholmen, and just down the hill, there's somebody who has sensor on their balcony, and they put measurements out every day, and there's a ton of historical measurements as well. And I couldn't find anywhere a predictive model predicting the air quality, because it's obviously correlated with weather. Right? If in Liljeholmen, if the wind is blowing from E4, the road, there's it's blowing in, and that's not hard to predict. And you can imagine people who have asthma and so on can. So I think there's a ton of society is digitalizing and data is becoming available, and AI is also coming on stream where people can train models. But how do you put those things together? And I think the other challenge, and I'll tell you why the surfing thing we did in 2004, we built a system, it went offline, and he was one of Ireland's richest guys who built it, but it cost $100 a year to run, and we didn't have any cash. So we just said, we're not going to host it. So, what the idea with the course is that you build and run this thing for free. Only free services. So GitHub Actions for compute. GitHub, if you're familiar with everyone's got GitHub if you're a developer.
If you're a decent developer, you're here.
Yeah, and you can, I think it's like 3,000 hours of compute a month you get for free. You can do a user interface in GitHub. There's something called GitHub Pages, so you can, if it's something that's being updated every day, it's free. Or you have Streamlit for interactive user interfaces, it's free. And then we have our Hopsworks platform. We're providing two things for free. We're providing state, so management of data for free. So your data for AI, what we call features, and then second are models. We'll manage models for you. So in our platform, you can store your models. You can even serve them, and you can store your features and serve them. So that's the data part. So you've got the compute, there are many different serverless compute platforms that run Python, and GitHub Actions is just one. I think that, people, when they go to GitHub, they'll see a button called Actions. They've no idea what it does. So I think when you say, I'm going to do GitHub Actions, they go, I'm curious. That's kind of interesting. But if you say it's some random platform that they've never seen or whatever, it's like Hopsworks, then they kind of go, I don't know if I want to do something else. Because the big problem everyone has when they start is the explosion in AI companies and offerings. Who knows what to do? It's really hard to decide what to do.
But okay, so let's reframe the question and not leading it in any way, because I now understand even better. So what's the context where who do you see this? If it's in the enterprise, or is this for a startup, or how do you see it used?
I have two parts. One is I'd love to see people build just services and put them out there, right? And there is an enterprise element to it, right? Because we're a company, and I get time from the company to do this, right? And I get support from it. So the reason why I'm doing it as well is because we're seeing at very large enterprises a lot of product, let's call it product-led growth, right? Is the kind of term that's used in the business world. If I'm working at a company and I've got a job, I have to do a POC. I have to do a quick POC on, and I'll show a stakeholder or something. And maybe we've got AWS, and I have no idea how to put all the things together, but I did this quick course here, and I know that I can put together a prediction service and show that to them by next week, even though I won't be using the company data, but I just want to show them something, right? Then just do it on our stuff. Show it to them and go, look, it's great. And they go, well, how did you do that? And I say, it's not on Amazon, it's on this, this Hopsworks thing. And they go, like, okay, maybe we could try that. I think what you've seen, like Databricks went that way. They went in, they market at the developers, not at the CIOs and the execs and the decision makers.
I think it's a very valid choice. You can do this in different ways, but this is valid. But in the end, the dream is to become part of the AI tech stack, so to speak, for the developer community, pervasive.
Well, I think what's interesting with this course is it's the first new serverless machine learning stack, right? There are a lot of companies doing serverless machine learning, but there's no stack, right? So if you're going to train models, here's the most interesting development, I think, in the last 10 years in terms of our space. Open source dominates everything, and we love open source. We're open source ourselves. But you mentioned TensorBoard earlier on, Anders, and MLflow, great products, but No one's using them. At least if you go to KDH, they're all on either weights and biases or on Comet ML.
I think that's a bit understatement. I think people are using them, but yeah.
Yeah, but I mean, look, I see them at KDH, and it's because it's just like Dropbox, right? Once you dump it up there, you know it's there. Like if you change your laptop, or you can even look in your phone, or it's still there, you know. And you're not paying for it.
Service.
It's a managed service, and it's free, and you know what you're offered is good enough. The free part, and I think that's been a big shift. And you know, we're at some level we're trying to ride that wave, right? We're saying, okay, well, why don't you put your features up here? You know, why don't you put your models up here as well? We'll kind of manage them and make them available to you. So I think you know that's a big developer movement. That free managed services have, for many areas, been more attractive than the open source alternative. Because the open source is great, it's free, it's yours, you can do whatever, and you can build a company around it. And the other thing you can't. But developers who just want to do something quick and dirty and don't want to have to install a MySQL server for MLflow, they're kind of like, I don't want to do that. And then there's issues with that. And, you know, I don't know where I'm going to run it, how will it be accessible, is it behind a firewall,
so
all those
would it be fair to say that, I mean, for one, you have a way for people that want to build prototypes or POCs that they can quickly do that more or less free, and it's going to be served and managed by Hopsworks.
Yeah.
And then if it works well, I mean, then people can potentially turn into, I mean, you must have some business model as well on top of this. Can you speak more about what's the business model?
Yeah, I mean, Hopsworks is a platform we build from the bottom up. We build the file system, the database, and the whole platform. So we started out selling it on premise, so because we could install it at customers and so on, and we still do. We still have customers on premise. But as soon as we got our first venture capital money, you know, we had one who's there. You're going to start selling. No, we're building a cloud managed version. I was like, we got some money. We're going to build a cloud
like
managed.
Opposite, like
no, it was like
even the VC said we're making it cloud ready with your money first. He got that.
Yeah, it was like, you know, that was, we knew we had, if we didn't build a cloud managed version of this, then it would be, you know, game over. So we have a managed cloud version where if you have if you're a large enterprise, they typically will not let the data leave their account. They want everything inside the account. They don't want it phoning home to your platform. So if you want Hopsworks in the cloud, you can go to our website and you can link our account to your account. So you typically talk to your IT to get that done. And then we can start the platform in your account and, you know, connect it to a bucket in your account.
So the data never leaves the company.
Yeah, it never leaves the company. And then you can scale the cluster up and down, and you can stop it, you can back it up, you can upgrade it. All this, the operational effort and overhead that you know you would have if you're on premise, you don't have. You know,
but the key story here, and I reflect on it from other examples, is like to go full SaaS on this topic and get them to their data to leave their inside their firewall, to go all the way over here, and you know, pain, but to go PaaS storyline.
I mean, these words are so. You know, we in turn. So when the whole platform is inside a customer's account, that's where we see at least most of the the enterprise.
So the key trick here is like they're running their cloud, whatever preferred vendor, one of the big threes probably.
Yeah.
And then in this context now, they don't want to leave their subscription. They don't want to leave their home, so to speak.
No, they're not. No.
And so here instead, we are talking about a model. So if they want to use it enterprise-wide, they take your software and they can now run that.
Inside their cloud, So typically people talk about, in this space, we talk about two layers. We talk about the control plane and the data plane. I think, I don't know who introduced that terminology, but what it basically means is you go to, let's say, hopsworks.ai as a URL, and you see your account, and you can see any clusters you have, and you can stop, start, and upgrade them, and so on. That's happening on our user interface, but it's talking to the data plane, which is the platforms running in your account. So the only thing that's happening is we have a little hole where we can send a message over and back, and we can see if everything's working, and you know, heartbeat to see if it's alive and so on. Yep. But otherwise, there's no data. We don't have access to it or anything. You know, so that's kind of the business model, right? So to sell that, and it's, you know.
So then you're hoping
it's pay by use, you know. So you're paying by how much you use.
So the business idea is then to be part of the AI developers workbench to some degree.
Yeah, I mean, I think like we didn't talk about the product itself, but primarily our users are using it as what we call a feature store.
I think we should move that directly.
Go there.
It's a big thing. So
good segue.
Yeah.
Because that's what you're marketing, I think, or is one of the big USPs that you have. So let's start with that. What is really a feature store?
Great question. So a feature store is, one way of looking at it is it's a data warehouse for the data that we use to train machine learning models, but also to make predictions, or what we call inference. We make predictions with the models. So it's a data layer where you take the data from your enterprise, which we talked about earlier in the lakehouse, or wherever that could be, and the data that's in your lakehouse, examples you'll see often are, imagine I'm trying to predict occupancy at a hotel, right? So my lakehouse may have a lot of data related to bookings, right? But when I train a model, I'm more interested in the vacancy rate as a feature. So we use this term feature. A feature just means like a compressed piece of information. And the vacancy rate is a really good signal for indicating revenue. So I'm able to understand historically the vacancy rate based on other features such as the level of corona panic in Europe. If that was a feature, I don't know, probably be a great feature to get. You could probably get it from Twitter sentiment, I don't know. These pieces of information that data scientists can extract from the data in the enterprise are what we call features. And creating those features takes a lot of work. You have to write some code to create them. We call that feature engineering. You have some logic that you say, here's this feature, here's that feature.
Which is exactly, you're doing transformations in order to get to a new piece of data.
Let's take the hotel occupancy thing. So you've got a table with the bookings, but I have to write some code that computes the average occupancy on that column over a period of time.
So you do two tables, you do something, a compute, and then you have a new data point, which is now occupancy, which is a combination of the old, more granular raw data points.
Exactly.
And this is now a feature.
Yeah, exactly. And I'm
spoken by the idiot.
No, but I'm giving another one, right? With credit card fraud, we're going to do in the Surface ML one. So in credit card fraud, you can have attacks like what's called a geographic attack. And I think most people know if you use your credit card in this point, and then within a short period of time, you're using it very far away where it's not feasible to make that journey, then that's indicative of fraud, right? So how do you compute that? Well, you need two data points, don't you? You need the location, you need the time of the previous transaction, you need the location of the new transaction at the time, and you can compute those together. So that's what we call feature engineering, computing features, and this is what data scientists typically will do. And when you compute a feature, you can use it in your model for credit card fraud prediction, right? But imagine I'm using, let's say, my credit history for fraud. But wouldn't that be a great feature to also decide whether you're going to give me a loan or not? Wouldn't it be a great feature to decide if I'm, I have an insurance claim that I put in, and if I'm a bit sketchy, I probably don't have such a good credit history. That would be a good feature for that as well. So what you find is that in larger enterprises, they spend a lot of time creating these features, and they haven't been reusing them. They've been rewriting them. Different teams have been rewriting them, maybe completely differently, and some companies, around 2017, the first mention of feature store came out where Uber said, well, we centralize all of these features. We put them in one big feature store. Think of it as being a data warehouse for AI. And what it does is it makes these features available so that data scientists don't need to go and rewrite them if they're there. And also it makes that data available to a model that maybe needs the feature. So I'll give you another example of why feature store is interesting. Most people are writing stateless applications these days. So if we take our credit card fraud example, and I have a credit card transaction arrives, I just know the location of the transaction, the amount of money that was spent, maybe the category of goods that's purchased, but I don't know any history. I don't know your credit card history. I don't know how many transactions have been performed in recent time. That's a great feature. That's called a chain attack. And if I knew how many credit card transactions you've done in the last 2 hours or 1 hour, then I might be able to flag for fraud if I think it's fraud. But the applications that make those decisions don't store all the history of your credit card purchases. So where do you get that information from? This is where we talked about earlier, the data engineers laugh at the data scientists, say, how can you get that in the production system? Because they know that it's a stateless application that won't have that history. And it won't also have context. Is there a lot of fraud happening in this town right now? Because that stateless application doesn't collect all that information. So the feature store can give you history and context to your models in production. So it's not just the data warehouse for reusing features, but also this operational platform to give history and context to models.
Right. And if we compare it to, like, let's say, take a traditional data pipeline or something. You have something running, every hour or in a streaming processing kind of fashion. How is that different from a feature store?
Well, I mean, it's not that different in the sense that we call them both pipelines.
Yeah.
I mean, it's code that's executing, it's computing something, it's outputting. So it's taking data, it's input, and it's outputting. I tend to go.
Is it the purpose that's different potentially that you have is being used for AI purposes to feed into some kind of model or system?
I mean, ultimately, the code that you use to compute features, it's just functions, and you're going to test them in the same way. You're going to have DevOps in the same way. I don't think it's fundamentally different. We tend to do certain things. We tend to do aggregations. We tend to do validation of data is more important maybe in machine learning. You put in a null or missing value, the whole thing blows up. We tend to do things like dimensionality reduction. We have a huge amount of data. We want to compress it. I want to match your CV with this employer, so I take this huge CV and compress it to 50 floating point numbers. It's an embedding. And then we do things like transform our data. So if I've got I want to train with a gradient-based model, I got to have smooth data. I can't have all this spiky stuff. So I'm going to transform it, normalize my numerical features, and so on, and one hot and code my categorical variables. So there's some things we do a bit different in terms of the pipelines. But fundamentally, it's still the same, right? It's the same. I don't think there's a big difference in the principles. I think one of the things that's different is we tend to like Python for it,
But so, well, if I may think, one potential difference is that the data scientist that is using data and building some kind of feature engineering for training the model, and then they're going to serve it, in production in some way, and usually when you serve something in production, the feature engineering or the data processing that's going to be used then is different. I remember this classical talk from Google once. They're going to build this kind of quick access thing in Google Drive that's going to recommend you what document to open, basically. And they had this exact example of having a training data pipeline or feature engineering part that was slightly different, because in production they had an API that they used, and that API apparently had some additional logic in it that was different from the training feature engineering, and that caused like a big training serving skew or simply a big problem. It didn't work in production as it did in training. Is that something that Feature Store can help with?
I mean that's I didn't want to go that technical, but we do use the term training serving skew. To say to describe exactly this type of problem, where people would have maybe written the production system in Java because it's quite high performance, and then Python for training, and they implement the same feature in two different languages, one which has higher floating point precision than the other, and you can get differences, and then they manifest themselves in bugs that are really hard to identify. So I think Uber flagged this pretty early, that this was one of the things that the Feature Store would address, and I mean, the way, like ultimately, what we find is that, a lot of when I talked about the feature store being managing context and history, there are feature pipelines that update the context and history. They're pre-computed features. You just look them up. So in serving, you don't need to recompute them. You look them up. But there will be things that the user enters. So we talked earlier, for example, about the geographic attack in credit cards, right? So that geographic location, it's not coming from the history or context, it's coming with the transaction, right? So what happens is I need to get that particular location, and I now need to find out the location of your previous transaction to compute the feature, right? Because in order to compute the distance between where you used the credit card the last time and the current time, I need to know history. And my credit card system doesn't know it. So I go to the feature store and I say, hey, give me that last location. You got 1 millisecond to do it, or 2 milliseconds, and now I need a function to compute the feature in my serving part. So this is kind of an area where there's different vendors do different things, or different people do. So
how do you do it?
Yeah, so in this particular case, we have a version Python library. So you develop a version Python library that you use both when you're creating the feature and also when you're computing it in inference. So that's typically Python. So we find a lot of the model serving frameworks now are Python based. So if people are hacking out themselves, they write a Flask server or whatever. We do something called Kserve, which is
What's the name?
Kserve. Have you heard of Kubeflow?
Yeah, of course.
So the serving framework for Kubeflow was more successful than Kubeflow itself. Yeah. Google, just stopped supporting Kubeflow when they came up with Vertex. Mm. But so that spawned out as a standalone project as part of I think it's one of these foundations, the Linux Foundation or something. No, it's I think it's the Kubernetes Foundation. Oh. So it's a standalone project called Kserve now.
Kserve.
So somebody told me it's like it was called was it called K-serving, Kubeflow serving, Kubeflow serving. Right. So somebody had the joke that they got rid of the ing, the hooking from K-serving to make it just K-serve. Okay. But yeah, I mean, in those kind of frameworks, the pre-processing that you might do before your model is all in Python. So, version Python functions work in that scenario. I mean, there are other places. If you're doing a transformation, you can do it in the model sometimes if you're using TensorFlow. And you can use scikit-learn pre-processing pipelines and just have them have consistent versions between them. That works too.
Mm-hmm. I have could you help me explore the value and benefits of feature stores in relation to scaling, and then contrast in relation to you want to do different types of, I would guess we could call it vertical scaling versus horizontal scaling with other teams. So in what ways is the feature store approach?
I mean, I think that's the real thing of the feature store. When we started, we talk about personas. You go to a big enterprise and you have a data team and they manage the data infrastructure. We talked about the data warehouse and lakehouse, and they manage that and they make that data available to the BI teams. And now they've been given a job and say, we've got this data science team we recruited and they want the data. And you're like, okay, how do we do that, right? And they're like, well, we can expose the data warehouse, fine, but I've got this online model and it needs access to the features at real-time, low latency. And well, my Databricks doesn't do it, my Snowflake doesn't do it, what do I do? So the data scientists, need access to data to train models. They need to know which features they will be able to use in production. It's not enough to say, oh, there's data in the data warehouse. Then, we had this problem again. That you can't use that in production. Don't be silly, But they need to have the confidence to know that, okay, if I create this feature and I publish it to the feature store, it will be available in production, whether it's online or offline, or whether it's a batch application using it, or whether it's an operational system that needs to get that feature in 3 milliseconds. And then finally, we have another kind of role, the machine learning engineer, who's supposed to pull all this together. Often they're computer scientists with some machine learning background. So the feature store is a place where those 3 groups of people can work together on putting AI into production. And that is not the case at a lot of organizations. It's throw the data over the wall. Here's a dump. Here's a CSV file. But, here's a model. Go productionize it.
And my prediction now is that this becomes more and more important, because let's go global enterprise scale. And we have several different data science teams working in different domains. So I'm working at Scania a lot right now, and I'm working in the bank part of Scania, right? Loan and leasing and all that. And here we have the marketing guys, and here we have so there are full-on data science teams with different perspectives what they need to do, where obviously the brilliance of the beauty of the value comes from mixing data. Yeah. So all of a sudden I actually want to do insurance based on driving behavior that I get from the engine team, right? Yeah. And all of a sudden now, in the same way as we want to share data, we probably want to share features between teams that are like in different logical domains. And I think here is sort of, if you haven't sorted this out, so I can have sort of an SLO and SLA on my features, how can I use that? Or should I build it myself? Should the bank data scientist build an engine feature?
Unfortunately, I think that's what happens. That's what happens, of the case. Right? Unfortunately,
but it doesn't scale, right?
And if we our customers are nearly all multi-billion-dollar companies who've gone through the pain of experiencing this and say, well, there's got to be a better way, and they read around and say, okay.
So here, this case fits quite well in this context, right? Where you have different domains with different data scientists, and they need data from each other, or features from each other.
Yeah, I think just organize. Also from a governance perspective and security perspective, that that all the data that's being used for AI is available here. In that sense, it's the same as the data warehouse was for business intelligence. That you would have this big data warehouse or lakehouse now that collects all the data from the operational systems, and now you can analyze it all in one place. The same would be true for AI, that if I want to train a predictive model that's going to predict something, I want the data at the enterprise to be available for me, where I can find that data, the features.
And a follow-on question. When we now look at a machine learning feature, how sophisticated where do you think we can make these features actually to be stored? How sophisticated, how smart is one feature? Because we want to have a coefficient, to compute, that's a fairly simple algorithm. How far can you go?
I mentioned this thing before we call dimensionality reduction, which is kind of a big word, and it kind of what does that mean, dimensionality? Is that some sort of space thing? I don't know. No, but
Star Trek.
Yeah, I mean, like, I'll give you a very simple example, right? Did you ever search for images and you say, oh, here's an image of a sunset. Show me a similar image, right? So how that works is you just take the whole image and you can use something called an embedding, which is a machine learning model that you train, and it will take the image as an input and give you out just a lot of numbers, floating point numbers. So it can be, maybe 200 of them. That's all. So it's
to represent the picture
yeah.
in numbers.
In numbers. So you got 200 numbers which represent this big image, which is
big sunrise. It's these 200 numbers.
And the amazing thing about these things, embeddings, is they also keep some of the structure that's in the original image. So what you can do is you can go to a database, something called a vector database or embedding store. We actually have one. I'll pitch one. We have one in our
embedding store is part of the feature store.
Well, we're building on OpenSearch for doing free text search, and OpenSearch provides the embedding store, so you can now use it in our platform. But that's we're not.
Which one? If I may ask?
Which one?
Which one are you using?
Well, it's OpenSearch has a KNN plugin, and it supports FICE, and it also supports NSM lib. So
Facebook version.
Yeah, the Facebook FICE. So that's pretty much the dominant one. Yeah. It's actually really nice because they provide security and filtering and all the good stuff.
Continue the story.
Yeah. So you said how complex can one feature be, right?
Yeah,
so
exactly.
I can just take one image, turn it into one feature, this embedding, and I can go within a millisecond get me back the 100 closest images in maybe a database with billions. And it's not easy.
It's that easy, right? Because as soon as you have made it into a function of some kind that is that this is the embedding function we're using, I can store that.
You just store it in the database, and then there's an index, and this is what Anders mentioned. What's the index? Well, it's FICE. You're going to get into the details. And indexes are ways of looking up data quickly, because you might have billions.
And the real use case here is, of course, massive industrialization and speed in terms of reducing, the craftsmanship time it takes to get something done. To use fucking call it, right?
Yeah,
more or less.
Yeah, I mean, the use cases for vector database in new space, and it's growing very quickly. We see it. We see it in recommendation systems, very much so. So if you've been searching for something, or if you go to a retail, Amazon retail, or any of these, they'll store your history of the session. What have you clicked on? What have you searched? What have you looked for? They compress it all down to a little embedding, and then they say, okay, what should I recommend you based on what you've looked at? And the thing is, there's a little bit more work to do after that, because they don't want it all to be the same type of recommendations. They want a bit of diversity, and maybe they want to remove things that you've bought already and so on. But otherwise, that's the basic core of it.
But I just want to step out of this nerdy stuff for 2 seconds.
Haven't you done that for a long time?
No. Okay. No, I want to go even bigger in terms of how big fucking deal this is. Sorry for my language. This is one of Lale's pet peeves, right? What's the difference, and how huge is the difference in industrialization of practices if you have worked at Google to the average enterprise? And he likes to compare it with craftsmanship versus industrialized. Yep. And I stole that from Lale, and I kind of say, you know what, the way you are doing machine learning now is like the Gas Monkey Garage, discovery reality show.
Yeah.
And the way we want to do it is like the BMW Stuttgart real machinery, right? So the difference is sort of, when are you going to stop dealing with this stuff as craftsmanship, and when you're going to do it industrialized? And when you get the industrialized hat on, then these things matter.
But I think it's more than that. I think it's tooling as well, right? I think, a developer, if they had their embeddings database available to them 5 years ago, they would have been able to do this cool stuff, but there wasn't any.
Okay.
But Google had one.
Yeah,
Facebook had one.
Because they built one themselves.
They built one themselves, yeah. So, like if we...
That's true. That's
but it is very true. And I think, you will see, I've talked about feature stores and history and context. Imagine you're building an operational machine learning system and it's not able to use history or context to make decisions. Can you build something really good and smart? And how many companies have feature stores? Not many. It's new. This is new cutting edge stuff. Right?
But it's crazy, right? How many years have Google and Facebook had that in their tool set? Because they built it, they figured this out.
Yeah, I mean, look, we actually organize a feature store conference. There's a global once a year. It's on October the 11th, and we had about 3,800 people registered last year, and this year it's a virtual event. And we have like Uber, who released the first feature store, but LinkedIn and Airbnb and DoorDash, all these companies, they built them all themselves. Yeah, and Google, they built them themselves. But they're not talking this year because they're, I don't know, whatever. But so they built this themselves, of course. And
when? How many years back, roughly?
5, 6, 7.
5, 6. And in AI years right now, it's huge.
Good question. I mean, it is. It's a lot, but it's enough time to really build. Just look at the top.
Pre-transformers.
Now you're throwing out buzzwords. Now you're just throwing them over the wall there. Yeah, but you can create a competitive advantage that's long lasting because of that in that short period of time. Just look at the top companies in the world by market capitalization.
Yep. So the reference I was trying to make was how fast transformers went from academic paper to full blown production mainstream type of.
Oh, that was very fast. I remember introducing.
So in that context, 5 years is a long time.
So I taught the first course in deep learning in Sweden, actually, which is kind of shocking to me because I applied for it in 2014 as part of the EIT master's program in data science, and I think it started in 2016. Was there 17? I don't remember which. It was 17 or 16, and I remember in 2007. It was probably 2017 now that I remember because. Transformers was based on a paper that came out at that time.
Exactly.
And
attention is all you need.
Very good. I didn't want to get into details, but yeah. So I remember in the course, I said, "This is so cool." So I introduced global and local attention in the course, and people were going, "What's this?" This is very interesting work, And now it came out. Now, if you want to say that how that time is shortening, the most interesting one right now is, of course, that we saw DALL-E, which OpenAI developed. And within, how long did it take to make an open source version that fits on your phone? There's one on your M1. You can run it now. I think it was
3 months.
It didn't take long,
No, so the point is this: like in that context, when the big tech giants have had something for 5 years, and perfected that for 5 years, is massive. That's the point I was trying to make.
Yeah.
I mean, perhaps you can rephrase this a bit more into a question about what is the possibility for a startup like Hopsworks to compete with big tech giants like Google's and the Ubers and whatnot of the world? And for one, we've seen that happening in Sweden a number of times, like Spotify. I mean, it's fought against Apple and Google and Facebook and so many, and Amazon and so forth. So it can happen for sure. But it must be a bit hard, right?
Oh, yeah.
What is how can you compete with having like a platform for data and AI with feature stores while other big tech giants are doing that as well?
It's a really fair question. I have to handle it with investors all the time, of course, because we have many things going against us. We're not in the valley. We don't have the deep capital reserves here available that they have. In our case, I really think it's just tech, right? Deep tech. So RonDB, which Mikael Ronström developed originally, it's actually the world's fastest key value store. And it's built here in Stockholm, right? And it's been benchmarked. If you benchmark today, you'd be able to benchmark over 1 billion transactions per second. Not just an operation, but a transaction per second. Now, 1 billion per second is a gigahertz. So if you think your CPU chips, they're only going at 3 gigahertz. But the database would be able to do gigahertz of operations per second. So that's one of the things that's quite unique in our platforms. We're really proud of that. And HopsFS it builds on RonDB, sure, but it's actually the most performant hierarchical file system in the cloud, which is kind of like amazing. But we're not selling it. That hasn't, that doesn't lead directly to any business advantage for us. But what has is these multi-tenancy thing. So we enables us to be first. Being first in a new space is important, even though, you can say, wow, they came later and they did good or whatever.
So multi-tenancy in terms of cloud? Or
well, ultimately, where do you want to store your data for AI today? In the cloud for free, just to get started? Well, you can use the Hopsworks feature store, right? It's serverless and it's there today. And, we have a competitor, two guys out of Uber who started their feature store a bit after us. And they got 100 million in their last round, but they're not serverless. They're nowhere near that. So, how can we compete? I think we can only compete by being better at the tech, and then being able to sell our vision.
Is that?
I don't know if anyone. I'm talking about us personally, right? I'm not generalizing.
You have a big advantage, which is that if you have a company that is invested in AWS or Azure or whatnot, you can support them all. That cannot a single cloud provider do, because they right.
I totally buy that, and the example of that really played out that was surprising to many people. We're back at Databricks and Snowflake, but go back 5-6 years, and everyone said no. The data will be stored on. If you're in AWS, you store your data in Redshift. If you're on Google, you'll store it in BigQuery, and if you're on Microsoft, you'll store it in Synapse. But it didn't happen that way. The enterprises said, well, I like the idea of optionality, that if I buy Snowflake and I'm going to move from AWS, I can keep it on Azure or on GCP, and the same is true for Databricks. So I definitely see that as something in our favor. The other thing in that point is, for feature stores, AWS and Google, they're really just using as an upsell. So they say all your data has to be in BigQuery to use our feature store in Vertex. Or if you're in SageMaker feature store, all the data has to be on Redshift to use it, or S3.
Which pisses people off, of course. Well, especially if you're a Snowflake or Databricks person.
If your data's there and you're happy and you're fine, you can go ahead. But, if some people think, well, this could be vendor lock-in, but I think for really large enterprises, they're going, well, my data's spread out. And they're saying, and if they say, well, the solution is put your data in our data lake house first.
That's what I mean.
Before you can use it.
It's a pain in the ass to get there.
It's not always possible, because many teams, you just can't move for whatever reason, So... I think that's something, and it's an interesting space. Feature stores. We were first. We released the first open source feature store, and we the first commercial feature store as well, and a lot of firsts. But what happened, because the space became quite hot, there were I can think 4 companies who raised over $10 million in the States to build feature stores, and none of them are there anymore. So it went pretty quick. We had Spice Machine, Cascada, Rasgo, Molecular, and they're just in America, you go, okay, your Molecular $17.5 million, or Rasgo, just to build a feature store, boom, and then they realize, actually, this is too hard, so we'll have to pivot and do something else.
So we need to get to that whole story, what it means to get VC and in Europe and Sweden and all of that. But just to end this conversation, to flip it, we've all heard those type of statements. Who are Google or who are the big cloud vendors really afraid of? Are they afraid of a big giant, or are they really afraid of the start? The logical choice is what will happen is that someone is really doing something fantastic in a niche, and that explodes. I think so. The logic here is also what is, in a way, it looks on paper as the worst, disadvantage in terms of muscle, is actually the nimbleness and something else, and being super niche, being able to pursue something that you need to flip that to the main advantage. How do you?
I think every company goes on a journey in terms of getting customers, right? And you may have heard of this classic one, that you have the early adopters, the innovators, and so on. And feature store is still at the innovators, early adopters phase, right? So the main companies, you take large companies in Sweden or whatever, most of them aren't looking at feature stores yet, because they're still trying to understand AI. They're just at the kind of the exploratory phase. So I think for us to find those type of companies, we typically go outside, even outside of Europe. We have customers in the States and in Asia and in other countries. So there are some in Europe as well, of course, and in Sweden we have customers in Stockholm.
So,
as well.
So you're literally looking on a global scale at customers who has come some way on their journey in AI.
Yeah, and actually, funnily enough, the other one is that it's a hard sell to VCs. You kind of go, well, they want to see patterns. They want to see repeatability. And you say, well, I've got customers in insurance, in gaming, in betting, in in healthcare, in finance, in retail, and employment agencies. It's just like what they got in common. I say, well, they have data, and they want to do AI, and they want to plug them together. That's it. It's actually not more complex than that.
No, it's just another way of slicing the segments.
Yeah. I mean, they all face the same challenge, which is, how do we get our teams to work together? How do we share the features? And how do we connect the data to the models,
I think before we close the story about, how a startup can actually fight against big tech giants, I think, one really strong opportunity you have is actually that you are independent of the tech giants. That in itself, I think, is a really good value. That you have good tech, yes, but that I don't think is the most sustainable way to win. I think another way to phrase, how you started can win, and I'm going to paraphrase Daniel Ek. This is back in 2014 or something, and Apple was just about to launch their new third version of their music service or something, and they've been spending a lot of time and engineering on it, and everyone in Spotify was super scared. Shit, tomorrow or next week they're going to launch this thing, we're going to be bankrupt in 1 week or something. And they launched something, and it turned out to be, it wasn't that innovative, it wasn't really shocking. They basically copied some, existing services that are out there, and then it was nothing new, and then everyone relaxed. But there was one thing that Daniel Ek said that I knew, or it actually removed a lot of anxiety for me. And he said something, I think, very profound, which is that the company that can move the fastest is going to win. Spotify at that time had much more engineers working on a single service, which was a music streaming service, than Apple did, than Google did, than Amazon did. And even if they next week launch something that will have a new innovative feature that we haven't thought about, we will still be the fastest company to engineer and build a new feature. So we can take that, we can do other things, and we can move faster. So the company that moves the fastest can win. And I think that is really the strength of a startup. A startup can move so much faster than a big tech company can, I would argue. Would you agree?
I agree 100%. Everything you said resonates so completely with me,
Yeah.
And we had a very similar event. So I said we were first with the feature store and first with the commercial feature store. I remember when Amazon launched SageMaker Feature Store, there were rumors, I knew this thing was going. So we were watching the Amazon Innovate, I think it's called, and we were looking, he's going to do it. He did it. They even took the graphics, looked like our graphics. We were like, what? And then what we were most concerned with, the only other feature store that had been released was Tecton, and we were using the term feature group that Uber used to describe a table of features, and we said, what will they use? Because whatever they used, everyone else will use, and they used our terminology for features. We're like, yes. But what it did was, we were, of course, were concerned and said, okay, this is going to be challenging, but we were creating a segment. Right? This segment didn't exist, and this was like validation of the segment. Now the segment exists. Now the big enterprises are going here. So you because as an entrepreneur, you have to kind of bet against the grain. You can't just do what other people do and say, well, I'll do it better or faster or. You need to have either a large amount of capital or something to, but if you bet against the grain, if you have a bet and say, well, I think this is slightly different to what the orthodox thinking is now, that's kind of the essence of a lot of entrepreneurial, how you start up. And we took a strategic bet that we would build on this, and it kind of has paid off, so.
But in my terminology, to understand what you said now, it's almost like, okay, we are trying to red ocean, blue ocean strategy to create the blue ocean, and we want to create a new product category. We don't want to compete here. We want to compete against the grain.
Yeah.
And so in one way, you're the first mover. You move ahead, but then you have always a little bit to challenge. Does this product category even exist?
Yeah.
And here we have now, to some degree, when one of the big ones is trying and making an attempt at it, a splash in this, as you said, this product category is now proper. It exists, right?
Well,
So now it's good and bad now that you have a big competitor.
Well, it wasn't as kind of blue ocean bed as you would think, because what had happened was in 2017 in September, that's now 5 years ago, Uber wrote this blog post about feature stores, and I read it and I went, oh my God, we've got the infrastructure for this thing, and I'm gonna build this. And then Airbnb came out maybe 4 or 5 months later and said, yeah, we got one as well. And I went to some conference and I talked to them, and then I found out there's others who've built it. So I was like, all the tech giants have this, and they explained the motivation for having this platform so clearly. That it was obvious to me that
this is a sleeper.
Anybody who's going to put AI in production and particularly work with at scale is going to need this. So then I was like, okay, let's be first to build it, right? And in the company, people weren't. I had to try and get people on board, and I couldn't really get anyone on board actually, really, because everyone's busy doing this. We're building this scalable platform for AI development and stuff. And we had this student I'd worked with, Kim Hammer, who I convinced, and I really swooned him trying to say, okay, you're going to build this, and here's the paper, and so he came in and he was super fast, and he a brilliant guy, and he bootstrapped it, right? So we have now like Fabio and Moritz, who are Fabio Busso and Moritz, and they're leading it, and they're doing incredible work. But to get it started, it required dedicated focus for a period of time. But it wasn't a blue sky bet, because we thought, okay, this will exist. And I think 7 months afterwards, we got our first customer who said, we want a feature store. And it was the world's largest betting company, Paddy Power. And like, yeah, we think this is something we need. And we're like, this looks like a good bet. And we kind of went in on it from there.
Super cool story.
Cool. The time is flying by, so we have a large number of topics here. So perhaps we can try to keep the answers as short as we can.
You try.
Probably not going to work, but we can aim for it. Should we move to the venture capital kind of thing?
I think that's a good. We are still here, but we are now spinning another angle on the startup experience.
Yes. So, could you please speak a bit about how has the venture capital raising journey been for Hopsworks, and perhaps also mention a bit about the European, Swedish landscape versus US or China? How would you describe it?
Yeah, I mean, it's always toughest to get your first funding round. That's always the hardest, So, we were talking to some people here, and it didn't really work out. We came close to getting a funding round, and it didn't work out. And then I had the research money was going to run out, so I was like getting desperate. And said, okay, I got to get someone. And we pitched to Swedbank, and they were like, okay, we were trying to get the platform in there. And that's what really got the VCs interested, I think. So just to have built the platform, we built the platform, and then Swedbank weren't a customer at the time, but they said, look, we're interested in acquiring the platform. And that was enough to get Inventure from Finland to say, okay, I think, this is something. And then it was like, what's interesting about venture capital is you get someone who's called a lead in your round. So they said, we'll lead your round. It's 1.2 million euros. And we'll put in 600,000. I'm like, okay, what am I going to do with the rest? And I said, go find it. So I got some Irish investor, a colleague I used to work with actually, and they're like, okay, this looks good. And they put in €500,000, and we got 150,000 or something, I think, from AIC in London. So, that's the hardest, always getting the first, getting it started and getting people to believe in the vision when you don't have a revenue base. And, there was no notion of going to the States for that round, you get it locally. And you would think AI was so hot. This was 2018. It wasn't as hot then, It was kind of like, it was interesting, but it only really got, from a venture capital perspective, hotter in 2019, 2020, 2021. I mean, more 2020, 21, I would say. So, we raised that round and we had revenue, so we kind of were able to survive for, we're capital efficient as a way of looking at it, right? So we're mostly tech and we didn't grow out the go-to-market team so big when we were building the cloud native platform. When we built cloud native platform, the managed cloud platform, then we got some customers, okay, we're going to go raise funding again. And then we got in. This time we didn't get any investors from the States, so it's Inventure participated again, but Industry Funding in Sweden who led that round. So they've all been fantastic investors to date, so we're really happy with them.
So you spoke a bit in the beginning about, you can choose to build a tech first. I mean, you had the opportunity to having a research background and building upon that technology that you had, but still you can choose to then continue to just build up the product or the tech that you have, or choose to get customers as soon as you can, and then guide your development based on that. It sounded like you opted for the first one a lot, or is that
look,
correct?
There's different ways. People would say you should always, customers should decide what you're building and so on. And but Steve Jobs never said that. He said customers don't know what they want until you show it to them. And at some level, we did bet against the grain, and we said, that we would sell the platform on premise to customers like Swedbank and so on, and that was the pitch to investors. And then we said, well, by the way, we have to build a cloud managed version because there's no long-term future if we don't. And I don't believe that there is. I think you can see a lot of these enterprise companies who primarily sell on-prem, like Cloudera. They're not the future of enterprise compute, I don't think. So, it depends on your product. I mean, there's no one size fits all. I can't give advice to people and say you should do what we did, because I think we were looking at longer term trends and said, well, we have to be here if we're to be relevant. Yeah. And so we ran to get to there. Yeah. But
would you do anything differently if you were to be back in 2018, 19, something, when it comes to investments or venture capital?
I think we got lucky with Inventure. They've been a great partner for us. There's always small things you can do better, and I think one of the challenges you have, we talked about America with the States. I'm a professor at KDH coming with a team of 11 engineers, and the Databricks guys came out and they, I think, got 80 million within, and we're getting 1 million. So there are challenges. If I had a big pot of money, I think we would have done things differently. We would have just gone cloud native.
So you would say it's much harder, like startup or capital scene in Sweden and Europe than US?
For what we're doing, but what we're doing is enterprise AI, and I think historically that has been the case. I think it's changed a little bit recently. And I don't want investors to get annoyed about this, and European investors, but there has been more capital available for these. Like in Europe, we've had platforms like Elasticsearch from Amsterdam, Neo4j. We have MySQL from here. These are all enterprise data platforms.
Swedish ones.
Yes, impressive.
But they've all had to go to the States. They all had to move there to get the money, because that's where the VC money
really.
was.
I get frustrated with this because this is leading into a segue. Let's not go there completely yet, but it's leading about what are we doing right and wrong in Europe. Yeah. But if we let's stay here. Is it important for you, or how do you think about focusing on really wanting to have European investors and building a true European powerhouse versus it's not feasible? At some point in my rounds, we need to get to the States. How are you reasoning around where the capital is coming from?
I think capital is one thing, and then we need to be more in the States in terms of customers. That's yes, absolutely without that. But in terms of capital, I think companies, it's global. The market is global for capital. If you're to raise money in the States or raise it in Europe, it's a little bit more work in the States, but you just pay someone to do it. So, I don't think companies prefer one or the other.
But flip it. Do we consider Databricks a Swedish company today?
Or Spotify.
Or Spotify, to be really brutal, right? The Swedes love Spotify.
Or H&M or Volvo or whatever.
Yeah, but I think now we are talking this tech scene, and we are talking a little bit like in another way of a brain drain of startups that is ultimately it gets owned.
There's one easy way to find out where's the headquarters.
Yeah.
Where's the headquarters? And if the headquarters is in Sweden, it's a Swedish company.
Yeah.
And I mean,
I'm not sure that's perfect definition.
For MySQL, where I used to work, the headquarters was in the Valley, and that's where all the money went, and all the tech was here. All the tech. So the ethos and spirit of the company, because there are Swedes in the Valley running it.
But just to give an example, I think H&M, for example, a lot of people consider that to be a very Swedish company, and it's turning, in my view at least, to an increasingly Americanized kind of company, which I think actually Spotify has done as well, and a lot of other companies. I think that's really sad. I think there is a value of having like Swedish style leadership in a team. Would you agree that that's a shame that so many like Swedish companies that started out at least in Sweden are turning out to be more and more American type of companies?
Well, I saw it when I was at MySQL as well. That Swedes would come up to leadership positions and not feel comfortable because there was an American ethos being pushed.
Yes, exactly.
Because we don't have, and we don't in our company. We're totally Swedish in that people tell the boss like, "Oh, what are you doing? It's stupid," and whatever. The notion that decision making comes with your authority, with your position, just is anathema to us. So. I think it's a fantastic way of organizing people around a common vision to build something. And then the question is that after you've done that, and I guess this is the problem with shareholders owning and running companies, is shareholders kind of ultimately decide, And the journey that companies make in the venture capital route is that ultimately the shareholders are not always going to be from Sweden, and then they'll be like, okay, well, who's going to get the most value for me out of this company? And if they think that, and then there's the historical precedent, say, well, they took in American money, they went with American culture, it worked for them, so you should do the same. To say that you're going to, I can do it better because I'm smarter, and you've no historical precedent to prove that, then it becomes a harder sell, and you pick your battles. So
Is it important that we are sort of driving? I mean, it's like a little bit like I get 100 million here or 100 million here, American money, Swedish money,
Swedish money's better, right? Like right now, if you're, European investor money is probably better because Americans, their VC money, we eulogize the fact that they'll take bigger risks, but they'll also burn it straight away. They're like, I don't have anything to do with you.
And I'll ask you to. This is not fair to ask our founder, but from a societal point of view of Europe and Sweden, that we are sort of lacking tech hyperscalers. Let's call it that. Yep. Truly European tech hyperscalers. This should be our treasure. This should be our crown jewels, and we're not taking care of them. And so as a founder, you just want to survive, so you get the money you can get. But this should be of societal European concern, in my opinion.
100%. This is a question I'm very engaged in.
Let's talk about this one.
I mean, so if it were the 1800s and you were building out railways in the States, and the British were building them out, and said, "Okay, we're going to build your railways. By the way, you're not allowed to drive the rail cars. We run them too. You can sell some stuff. You can have the coffee shop in the middle. We'll keep 30% of what you sell from the coffee shop in the middle." That's where we are in terms of, because society is digitalizing. We're building digital infrastructure, and we do not own or control or have any clue about the cloud infrastructure that's powering this digital society. Europe has nothing.
And okay, we are almost transitioning in a topic now. Do you want to frame it?
I was so eager to go to another topic, but okay. Okay.
I think it's a great topic, and we got Jim started on it.
I'm sorry, that's my fault.
Great. I love it.
You pushed me.
I did it.
Keep going, Henrik. It's fine.
Yeah. So I think I had to talk in Berlin actually in April, and there's a lot of people from the EU there, and I've talked to people in the EU at different levels about this, and they mean good, right? But the problem is the accountability and the way we dish out money in the EU. There's a lot of money goes into some projects, but we're not allowed to do what the Chinese did. What the Chinese did was they said, right, Huawei, Alibaba, I think there's one other cloud, I can't remember.
Tencent or
Baidu? Baidu, sorry, those. Actually, Baidu were the ones who bought Flink or Verica, okay. No, it was Alibaba. My God. Anyway,
I think it was Alibaba. Yeah,
it was. Yeah. So they just said, here's our winners. We're going to pour the money in there, and now they've got their own cloud infrastructure. And Europe, because we're not, the Commission can't put 10 billion into a company. It's just not transparent. And how do you pick the country? So,
this is a problem, right? Because even if we go to lower, like national levels, Vinnova.
Yeah.
All right, and we are dishing out Vinnova money in the hundreds, when it needs to be in the millions to do. I mean, are we spreading it too thin?
Do you know the capital expenditure by Google, Amazon, and it's I think it's it's tens of billions of dollars per year. I mean, we're taking tens, we're talking about 50, 60. There's some good blogs out there where you can see these numbers.
Yeah.
And the EU thinks their biggest flagship project is 1 billion spread over 500, institutions.
This is the problem, right? So even if it's 1 billion, because it's diluted,
Yeah.
I would argue now, I'm using a language which is provocative. Is this the right way to get to a winner, or do we need to think carefully about how this is structured?
I think there's another, so here's the other part. The European companies are getting away, like the way we're framing this debate, they're getting away scot-free, right? What happened to Ericsson's, all these companies, they talk about the Lidl cloud, right? Have you heard about that, the Lidl cloud, no?
No.
Lidl are trying to build a cloud. I mean, so I think...
The grocery store Lidl?
Yes, SAP, one of the biggest,
Lidl. Wow.
Yeah, Lidl. And one of the biggest software companies in the world, SAP, who are now just diminishing. If they had bet on a cloud, they would have got billions from the European, and they would have built it, right? And it would have been great, but they never did. So so the companies in Europe are also getting away scot-free. It's like, it's the Commission's fault. It's not entirely, right?
You didn't do what you didn't pick it. You didn't pick it smartly enough.
Well, if one company had said, look, we're going all in, we're going to do it, right? I think they would have got the support of European governments, economies, and everything. And I think it would have happened, right? What I see happening now is there's a couple of European cloud providers who are sort of doing well. We have OVH in France and we have Hartner in Germany. I don't know if you know them. They're not big, like they're maybe turning over $1 billion per year or something.
What's the definition of doing well in this context?
Well, I mean, it's all relative to. So when people talk about the cloud, they really talk about 3 companies and 3 clouds. So it's Azure, AWS,
So, but
and GCP.
on a European scale, of course, we can't compare it right now to the big giants.
Yeah.
But in some way, they get traction. They have a fairly good offering, and they're finding niches that they serve well.
Yeah, and OVH were doing incredibly well until one of their data centers burnt down. They lost all their customers' data. So I think that's the problem. It's like we OVH were going big, and France were going to their dirigisme way of doing business was doing really well, and then something like that happens. Oh. So the software infrastructure wasn't there. Like they didn't have their S3 that would replicate the data across regions. So data was lost.
I think people don't understand how much effort and time is going to spend, building a cloud service.
Yeah.
I mean, for Google and Amazon and Microsoft, they just, they had so much internal services that they built just for their own purposes for tens of years.
Yes.
And then they started, can't we make money of this? And started to make a commercial service out of it. But they already built it for tens of years and spent like tens of thousands of man years trying to build it. And then other comes and says, okay, let's build something from scratch that's based on nothing. And it's not going to work. I mean, it's
it worked
really
for Microsoft, didn't it? Microsoft didn't have anything. They just did it from scratch, really.
I mean, they had a lot of services.
I mean, they're brilliant engineers. They're brilliant, but
it wasn't for scratch.
No, they had
so much internal services.
They had Bing, but they didn't really, they didn't have that expertise, I would say. But they put so much money and effort, and they turned the company on a dime and just said, "Look, we're going all in." And no European company dared do that. None of them dared take.
Well, Microsoft betted their existence, I think, on the Azure story.
Yeah, and Google have too, and it hasn't worked out as well for Google as they would have hoped, I think, yet.
Yeah.
I mean, they're doing well, but they're not they're not killing it like Amazon or even Azure.
But
I think Microsoft has another advantage that I shouldn't really speak about, but still, I mean, they have some biases,
yes,
right?
yeah.
But what can we be positive in terms of what should we do, or how should we think about this standing in 2022?
My take is the cloud's 1.0 is lost for Europe, right? It's lost, right?
Yeah.
If you want to do something here, you maybe have to go to Cloud 2.0. And what is Cloud 2.0? I don't know. It could be Kubernetes. Like it could be say, okay, we'll build a Kubernetes cloud and everything that's containers now instead of virtual machines. I don't know, but I think it's going to be really hard. And I agree with Anders there that it's just the effort and time, and it's going to be hard to build another cloud that competes directly.
What do you think about more vertical kind of cloud services?
This is what we had on the conversation before. Like we have very clear industry verticals in Europe. So why don't you build the best automotive cloud in the world?
Yeah, I mean,
or health cloud.
Cloud.
Yeah, well, there is this whole thing of what's called digital sovereignty. I guess you've heard of this notion that, and shout out to some of my friends here who run several nines. They have this database platform out of Stockholm as well, and Kalmar. So the 2 founders are in Stockholm and Kalmar, and ex-MySQL people, of course.
Okay.
And they're doing really well. And one of the places they sell is people who need to keep their data inside their national borders. So it's called digital sovereignty. The challenge, as you probably know, is that developers who are so influential now, they don't think it's cool, right? Digital sovereignty is just like, I don't care. I want to have the coolest tech. Show me the coolest tech, I'll go with that. And because developers are so important, they want the coolest tech to help them get the next job and to be at the cutting edge. And the cloud is at the cutting edge. And, you know, the open stack cloud thing that's local here, that's a bit messy, is not cutting edge and is not skills they want. So developers are agitating against it. So I think that's a challenge. So
you need to figure out how to please the developer community.
I think you do.
Part of the strategy
I
here.
think you do. And digital sovereignty needs to really become something that developers care about
cool,
and be proud of. Say, hey, you know, I'm proud I built this data system that doesn't leak our data to Russia or to Donald Trump. It's not on his floor of his office or whatever. You know.
But so we can spot a couple of core things that kind of you need to understand the mechanisms here. And if you're not hitting them well, it's probably not going to fly. But okay, so developer community, how to get them
on board
is critical one. What else?
I think another challenge, like, so the problem with verticals is that, you know, you can do Industry 4.0 cloud and say, oh, this is great, whatever, and we're collecting all of these data from this industrial machinery. And then they're like, okay, well, we want the best data lakehouse in the world to store this data. And do you know what? Like, we've got these images coming in here, so we also need to have this fantastic object store that's replicating across regions. And you know, now we need the best AI platform that's in there.
So
and
it's like general cloud.
It's like it's like general. You'll need a lot of it. Like So
what's vertical? What is really unique with the vertical is your core argument here, I guess.
I mean, look, I'm not saying there's none, but I'm just saying that often you'll find that, like, when the data has value, it kind of leaks out to that people more and more ways to process it, store it, and get value from it, and it's hard to do that in just a niche. I think in areas like medicine, where it's incredibly regulated, and healthcare, you can definitely have a lot of regulated vertical solutions.
Shouldn't that be a service that is surprisingly useful? I find it really surprising that, you know, given all the regulations coming up and already, you know, with GDPR, etc., that we've seen, that we don't have good cloud support for just being compliant with regulation.
It's hard to do when there's only 3 clouds to choose from, and they're all governed by American law that says they can act.
So isn't that the USP to have that the fourth cloud that is completely built ground up by design for the AI Act and for GDPR?
Absolutely.
I mean, like, I kind of...
I like it as well.
You know, whatever, right? It suits our public sector.
Yeah.
It suits our, you know...
Yeah.
I mean, Europe is going all in being, you know, the...
AI for good, or whatever we call it.
What's the motto? I mean, it's so different ones, but being some kind of sustainable ethics, human in a loop kind of, or human-centered AI. There's so many kind of different mottos here. But if they actually did provide a cloud provider that did not only help with the technical solutions to build something that can run on Kubernetes or be scalable and automated, but also help companies to verify that it actually is compliant in some way. You know, the AI, I'm not sure, how much are you into AI Act and the upcoming regulations?
No, I mean, we wrote a blog post about it as well, actually.
Awesome.
You know.
But I mean, they have the sandbox kind of things in it, and it's supposed to be, you know, trying to help SMEs and small companies being compliant. I'm not sure that works without actually having a proper service helping that. Saying that each country has to do that themselves, I don't think is a sustainable way to do it. Wouldn't that be a big opportunity for someone to?
I think it is a huge opportunity, but what we see often with startups is, we saw it with GDPR, is it helped the big companies because they had more money for compliance.
We say that all the time.
But if you're nimble and you base your strategy on it as a company and say, look, we're going to be the AI Act compliant platform from day one.
Yeah.
The Americans will be slow because they're not interested in it. It's too far away.
Europe is just one small
whatever.
market. Yeah.
But then you have the issue also, it's just like the smoking ban, right? I was in Berlin, I said in April, people are still smoking in pubs there. You know, like how many companies are not compliant with GDPR right now? They're just kind of like, you know. we're not big enough to get swatted yet, so we'll just kind of let it go. So I wonder from day one, how many companies will say, okay, maybe I think the big ones will care, of course, but they cared about GDPR as well. And like I know with Spotify, for example, it took them a while. Let's just say.
I'm keeping my mouth closed.
No, but I do know it took them a while.
But
like,
it's just,
when I say it took a while, it's like they weren't. I'm not going to try out accusations here, but like that's I think what happens a lot of the time.
Practicality.
Yeah, it's like we've got data on 100 million people, and you're asking me to delete it, but I'm in a database that's append only. What do?
Exactly.
It's like.
But this story goes somewhere that you can also. What is very useful to have an act that no one really understands what it means and how to interpret it, or how to be compliant. Maybe if you just take that imagination, stretch it to, we need to have a service, and all of a sudden you end up that if you truly want to drive the AI Act in Europe, then Europe needs to pay for the cloud. As a European Union, and God forbid to have a state or union-owned startup. I'm not thinking that.
No, yeah.
But the trajectory, if you want to execute on this law that no one understands, you kind of end up here. Maybe I don't know.
But it's like everything. You have all the layers, right? And if you're just deploying an AWS today, you're already in breach. There's the Safe Harbor Act between Europe, I think, and the States. You're already in breach of that, right? Like, and how many companies are in breach of that? All of them? I don't know. And do they care? So it's like I'd love to know that with security, that if I as a company turned our strategy and say, look, we're going to be the European AI client compliant, and day one they're all going to enforce it, and then I would be doing it because I know we'd be faster than the others and so on. But there's a part of me that also thinks that it's going to be like the Safe Harbor Act, that people just won't care, and companies won't care, and no one will push it, and then eventually there'll be huge fines given out by the Commission because say, come on, you're not. They'll make an example of you. But at that stage, the Americans will be all in and say, we need to do this now. So I think I totally agree. But it's like, and if I had bags of capital in reserve to go with this strategy.
Wouldn't it be an opportunity for Hopsworks as
well?
Yeah,
I totally think so, yeah. And like I mentioned several times, that this is part of their strategy, this is what they do. This is how they differentiate themselves. I think, but also like for a company like us, we could go for that, but then we would suddenly be painted as the niche kind of platform. It's like you're not. I think you need to be a little bit careful in how people perceive you.
It could be an upsell, just
Is it an upsell or is it your main core?
But here's the other thing, right? How many of our customers are in Germany? I can say Germany 0. They're not as advanced in the use of IT as Americans or many other countries.
Or they have a really strong regulation in Germany as well.
They do, and they love open source, and they love not paying for software. So but I mean, so there are other considerations,
tough questions.
Yeah.
Should we go a bit more philosophical, perhaps?
Go for it.
And one thing we spoke a bit about before was, where is AI going? And there are so many different debates and AI wars out there on Twitter and whatnot. But one is also about more symbolic AI versus more connectionist type of AI. We have the Jan LeCuns and the Hintons of the world, and we have Gary Marcus on the other side, perhaps.
Could you frame it a little bit more, baseline it a little bit more before you go too fast into this? I'm not following.
Yes. I mean, of course, it's been a big revolution, I would say, of course, for deep learning since, I guess, 2012 with the AlexNet and being able to understand images in a way by using deep neural networks instead of more rule-based, symbolic type of AI. And after that, it's been a continuous thing after another of using AI and deep learning for text, for images, of course, for videos, for audio. And it's also for reasoning and playing chess and Go and whatever kind of games and so many
genetics,
AlphaFold 2 and whatnot, solving genetics for that, protein folding, one after the other. But still, a lot of people are claiming that, of course, things are missing from deep learning. It's not the only solution to have AGI and we need more things. What's your thoughts about this? Do you think? Yeah, okay, I'll leave it at that. What's your thinking?
I'm definitely not in the symbolic camp. So Gary Marcus is not who I follow on Twitter. You know, I see him carping.
You can still
on the
follow
sidelines.
him.
No, I see his carping on the sidelines, and I'm kind of like, yeah, whatever.
Yeah.
But I'm a big fan of Hinton. I loved when I was younger, and in an academic, Hinton was like, wow, this is the best guy. And now since I'm more in industry, Jan LeCun is actually, I've switched a little bit more over to a lot of his line of thinking.
Yeah.
But in any case, I mean, some of the things that have been really interesting, I think, if we take a very simple kind of journey, right? So deep learning came out, and we had deep learning networks that were able to do single tasks like image classification.
Yes.
And then we've seen GPUs, obviously a way to accelerate the training of these networks. So we didn't have the data, we didn't have the compute, and now we have those. And then we see new types of architectures that learn architectures, like transformers. Like they can learn the architecture itself, the best architecture, as well as the so we've seen all that happening. But what's really interesting is happening now, I think, is multimodal. So you take DALL-E, right? So everyone knows you type in text, you get an image.
Yes.
Isn't that crazy? They're like, because before it was just image, or it was just text. Google Translate. Isn't
Did
that
you
incredible?
rehearse this?
No, but it's multimodal is a big thing.
But I must.
Did you read the Jan LeCun? He had this thesis that came out earlier this year about he had an idea for a new architecture for
JP
intelligence.
architecture, of course. Joint embedding prediction architecture.
And the energy-based models. I've had fascinating stuff. And I'll just throw in one line he had. He said, well, his architecture, he said, we also need a key value store to store short-term memory. And it's a feature store. So the feature store is part of his brain, which I was like, yes. Anyway, but I was very fascinated. I love his stuff, because I love the stuff he did on self-soup. He really led you remember this cake he had? He presented
of course, the cherry on top.
Yeah, and he said that the majority of learning is this self-supervised learning, and then we'll be able to have icing on the cake, which will be the supervised learning, and then the cherry is reinforcement learning. Or
so
like
bottom line, the biggest problem is it Jan LeCun's one of his pet peeves. Self-supervised learning is the next thing we need to really solve in order for to make the next leap. Is that a way to summarize?
I think that's a part of it, right? I love the way he talks often about he relates it to how humans acquire intelligence, right? And he always has there's this French pediatrician, I think, who has this model of the acquisition of intelligence, and he uses that as kind of a motivation for how we should go. And I think we're doing a lot of really good stuff in self-supervised learning, and I'm saying you're seeing a lot of progress. Multimodal, on the other hand, is kind of like still, we're still out there. It's like we can put two together. We have one task, now we're at two. I saw a really cool one was Tesla. I don't know if you saw this, Anders, early in the year. They showed that they're no longer learning images, right? They're actually folding all of the images together in the car into a 3D representation. This was like, wow. And then all the tooling you had for tagging, throw it in the bin, then it's 3D tagging.
They went to vector space, or whatever they call it.
Yeah, to higher dimensional, it's higher dimensional space. It means it's three-dimensional, right, at this stage now. So
this is so...
I think we have to move to the consciousness kind of discussion.
Yes.
But before we move there...
This is cool.
I'd just like to continue a bit on the multimodal kind of discussions, because the text-to-image kind of models that are exploding, of course, starting with DALL-E, but now, with Stable Diffusion, and I think one of my favorites is actually Google's Dream Booth that came out recently. It's anyway, I still find it a bit annoying, the level of attention that these are receiving in the press compared to the one that truly makes a difference in industry. So this is a bit of a rant that I always have, but if we compare something like Clip, it was a model that came out also of OpenAI that is also partly used by DALL-E, but I think the Clip one is really what's bringing value to companies.
I don't know the Clip one. What does it do? Tell me.
It's just that it can take images and text and have a common embedding for the two. So then it can find an embedding that is trying to show how similar, if you have a sentence saying this is a dog walking in a park, and then you have a picture of a park with a dog, then these two embeddings will be really close.
Yeah.
So it's more like going from two modalities like text and images to a shared embedding. And that's being used as ranking in DALL-E afterwards to find what's really working.
Yeah.
But that one, is so useful, I would argue, in industrial settings, in just being able to say, okay, I want to find something in a large piece of text, thousands of pages of text, or hours of videos, material that you want to search through or whatnot. That is, truly useful, but it's getting zero attention, I would say. Yeah. I'm not sure.
I totally agree with you. And this basic principle that you're describing, where you have two embedding spaces, and we actually work on this. I find it really fascinating. So recommender systems, right? Yeah. So if I store your history of what you've looked at and on the shop online and maybe in the session and in the past, and I convert it into an embedding, and then I recommend some things to you, and you click on one of them, right? So now what I have the items in their own embedding space, because the items have descriptions and properties that you can convert into embedding. So the items exist in embedding space, and then your history exists in embedding space. How do you bring the two together? Exactly, yeah. Where's the grounding between these two? Where is the shared embedding? And the shared embedding is when you click. When you click on the item that's recommended to you, and when you don't click. So I don't click on the other one, that's also an action because I didn't select it. That is the thing that we use to train the model to say, oh, you looked at all these things, you did these things, so I should show you this item. Because this item is close to this other item in embedding space, and they're now in the same embedding space. Because the click is the thing that brings them into the same embedding space. That means that I can take your history, this is the thing you recommended, so I can take your history as embedding and place it in the same place in the items embedding space.
Right.
But we're doing it for two modalities, and I had to spend a long time working out how this would work, and I was kind of trying to figure it out. And I was going, this is hard, these are called two-tower embedding models for recommendation and search, and it's there's not much you can find on the internet. Very little. I think one of the few. I talked to Data Summit about this, but there's very little you find. No academic research, but it's all new, and this is what people are doing for two modalities. So you remember the thing with when you're trying to I can't remember which philosopher or mathematician was the three-body problem. Two-body you can compute very two bodies you can compute linearly. It's quite easy, but then three is it's non-linear and then it's chaotic. So I wonder with embeddings and modalities if how easy will get us to get to three. Can we get to three? Yeah, that's it. Because the grounding of that, and I think for the recommender system, the grounding is I did the click. What is the grounding for? I type some text and I get an image. Well, that's the training from DALL-E. It's done that grounding for you. So that grounding has to appear from somewhere. I think Jan LeCun is onto really good. He knows that this grounding is going to come from a system that has to interact with the world, and those interactions become the groundings that bring the modalities together.
And I think the JEPA architecture, even if it's more a position paper, it's not really technical at all. It's just speaking about, how potentially we can reach some higher level of intelligence in the future.
He was pretty hard on contrastive learning versus regularization. I think GANs are hard to train. I don't know. So he's probably on something. But I don't know.
But we're talking Jan LeCun's positioning paper on what's the next step to AGI.
Yes.
And what is the core? What is he outlining as the core things to work on?
It has a number of components that he believes are missing today in the deep learning based only systems, like a configurator and different memory systems, key value stores that you mentioned, etc. I actually have my own definition, which is different, but still, perhaps we shouldn't go there.
Maybe they're smarter.
No. Of course, he is my hero for sure.
So after work, we're gonna kill him and put the real smartness on.
He's great. He's telling people it's a big thing to go out and say, look, contrastive learning, you probably shouldn't be looking at this. And you can there's thousands of armies of PhD students in AI who are saying, I'm not going to do contrastive learning now.
And he's really moving.
But he's been right for, I think he's been right with self-supervised, he's been right with convolutional nets. And so I think people are kind of trusting his judgment. And so
basically getting hints, where is the value to go further?
And Hinton has been incredible for a long time. And then he came up with, you remember the capsule networks?
Yeah, and it died out.
It died out because they weren't computationally feasible. Because he's not a systems guy. So he didn't realize this couldn't be parallelized because he had a bottleneck of voting. And everything has to be parallelizable. And, that was why it kind of died out. And,
Let's move to the direction of consciousness, and I had a couple of angles there, but frame it the way you were planning to frame it.
Yeah, well, we spoke about Tesla cars, so I think we should start in that.
I think that's what I was starting.
Yeah.
What's the real problem is one angle.
So Elon Musk, if we follow his thinking, and this was one podcast with Lex Fridman once, where they spoke about how Tesla car works, and of course they have one part which is the perception, basically turning the camera input into some kind of vector space, as you call it, and they are using all of them together instead of separately, and in that way being able to have a really high performant, like the vector space representation of the world. Then the second question is, once you have that vector space representation, basically this is called a world model in Jan LeCun's kind of description of a system. So once you have this kind of world model, then the question is, how do you act and how do you take some actions? And in that way, you have to choose, you basically steer left, right, brake, or gas. So then the Lex Fridman's question was basically, which is harder, to do the planning, to know what action to take, or to do the perception of moving from sensors to some kind of world model? And I think a lot of people think that deep learning fixes the perception, the hard thing is really the planning and how to take actions, but Elon Musk said exactly the opposite. So it basically said, without a question, the hardest problem is perception. Once you have a clear understanding of the world, have a world state, or as he calls it, a vector space, the rest of the problem in being able to know what action to take is really simple. And he made a really simple analogy with that, saying, well, just take GTA, the game of Grand Theft Auto. That has, it is rendering the world, so it knows exactly the world state because it uses the world state to render something. So it knows exactly how the world state is. And then the question is how to move the cars around autonomously, which there are a lot of them doing in GTA, which is super simple. You can just have a single rule-based system if you want to, and that's efficient enough to know how to plan and take actions. So what he said is basically, okay, it's super simple to take an action. Okay, given all that, it's just the framing. The question becomes then, also given perhaps what Blake, Montague and others said, before, that the Lambda system that Google had is conscious and sentient, and potentially that it should be getting human rights.
Human rights, yeah.
We shouldn't move there. We're digressing.
We're all
here.
laughing about it. So.
Yes. But still, the question then is, what is really consciousness? When does a system become conscious? And potentially, I would argue at least, that Tesla car is conscious. But it's a very narrow context. It is nothing like the general type of consciousness that a human has. I would even argue that potentially a chess-playing AI is conscious, but only about the game, about the current state, and about what actions to take. And it's extremely narrow. Just as you have narrow AI, narrow intelligence, and more general AI that can work on any task, you can potentially be narrowly conscious about a very, very simple world.
We've been exploring this with a couple of... We came up, after, you need to drink 4 beers. Then you can come up with a new...
look, another beer.
New definition. So narrow consciousness, right? Is there such a thing? How can we... And we started this conversation with Fredrik at the robotics, Mr. Robotics in Sweden.
Right, yeah. So, I mean, I think I agree with you. Consciousness is a spectrum. I think we can agree on that, right? It's not I would argue that chimpanzees are conscious to some extent. They can communicate, and many people argue free will is the term. Where do you draw the line? Free will. I mean, so is a chess playing thing free will? I don't know if that's.
Are humans real? Does human have a free will?
I don't. I know. We know the answer to that.
Depends if you're married or not, right?
Touché. But no, I think like if we because you gave the example of Tesla, I think it's really interesting, and I'm going to shout out to Martin Nielsen at Rice, who's been doing incredible work on the brain, and I've talked a lot to him and Sverker Janssen as well at Rice, and we've had a lot of interesting conversations about mostly about brain function and not so much about consciousness per se, but one of the things that Martin makes point of is that at the higher level in the brain there is definitely linear operations happening, and this is when Elon Musk says, oh, once you have a world model, it's easy, you just then make a rule-based system and so on, but there is a gap between are sub-symbolic and the Gary Marcus symbolic world. And the brain is definitely getting up there. There's something happening up there. And there's definitely multimodality coming in because, data is coming in, it's being sensed, and it's being represented in some way or form. And that data is being brought together. And, a lot of people will make fun of do you know this guy Jeff? He invented the Palm Pilot. He wrote some books on consciousness. What's his name? Jeff something. Anyway, I read a couple of them. I thought they were actually quite good. Right? No one takes a stab of what the brain is, and he believes that the brain has. He said it many times that there is one mechanism, which is evolutionary mechanism, which is the neuron and how they communicate and so on. And the brain has just grown by replicating that mechanism. It's not like 5 million different types of neuron cells doing 5 million different things. There's this, and I think it was Werner Mountcastle who came up with this thesis, right? But what we can see is that there is emergent behaviors at different layers in the brain, and that emergent behavior comes from many different sources. So you've your multimodality data, and like I may be talking to you, and I'm not taking in my surroundings, but that information is getting there, and then a signal comes, and my attention suddenly focuses on that because it's gone up from my subconscious, but it's registered my subconscious. What does that mean? I think that's where we don't know. What does it mean? It's left my subconscious to my conscious, right? The magnifying glass is a good one. The flashlight that kind of shines around, and the flashlight might get pulled here or there, and we say, well, you're not conscious because the flashlight pulled you there. Yeah. But you can pull the flashlight back, can't you? If you want.
Yeah,
and for me, consciousness in free will is pulling the flashlight to where you want to put it, and the ability. And why you do it might be, why do you do it? I mean, it's a good question. You might do it because you were trained to do it, or you experienced something, or whatever. But if through an act of conscious free will, you can move the flashlight to where you want to move it, to me, that's consciousness. If that makes any sense.
Yeah, but it's the tricky part here, I think, is. We all know, right now we're in the state of fairly narrow problems we're solving, and we are getting within that narrow space quite intelligent. And then you can take the sort of AlphaGo example, where sort of moves were made that hasn't been made in 2,000 years. Then you can argue on what level is there a deep consciousness in relation to all the games that has been played in AlphaGo that this can be done. So, then you can argue, taking back your analogy on the flashlight, well, the computer choose to put the flashlight on a move that no one ever has done before, that no one could figure out, that was fantastic.
But that choice was predictable, right? Because the algorithm is...
So
we'd have randomized algorithms that might do this in a non-predictive way, sure.
So I think what I'm trying to say then is that, well, we are back to its spectrum, right? So within a very narrow spectrum now of only AlphaGo and all the learnings in that, it made something that appears conscious in relation to only that, but that's not general consciousness, of course.
I hear what you're saying, and I understand the point behind it. But let me reiterate a point. And I remember the guy Jeff Hawkins. I actually looked it up there. So Jeff Hawkins is the guy who wrote this book, and I saw something similar when I read Jan LeCun's position paper earlier this year. And what both of them talked about is that, and I found this is fascinating because we talk about multimodal, and imagine you have one modal, right, which is just like we talk about the visual system. So my peripheral vision. Right, so I have that modality. What's happening all the time is that when I was born, I was a blank slate at some level, and I learned to predict things. So I looked at things, and I built small little predictive systems to say that if the visual scene is like this right now, and it continues to be like that, the prediction said it was that no information, zero information, new information there, right? So your brain is full of all of these small little predictive systems from all of the senses that we have, plus the thoughts that we have going around, and they're making constant predictions the whole time, all of them. And if there's no new information, it's not bubbling up to consciousness. So my consciousness, this flashlight I have, doesn't need to go move left or right because the visual system didn't say something scary happened, a car came in from the left-hand side. But if the prediction system that's in my peripheral vision is running in the background, I have no conscious awareness of it, but then suddenly something unexpected happens, it says, oh, information, and it goes right up to consciousness, and then I move my head. is that consciousness? No, I don't think so. I don't think that's free will or consciousness. I think that, you can have a machine doing that, of course.
Of consciousness, then?
Well, then we're back to the flashlight, isn't it? That like this thing that is focusing on something at the moment, if I'm able to, for whatever reason, be able to steer it. And you can say, ultimately, how are we motivated? And you can say it's our reward system, whatever that is,
but
or evolution.
If we take like Kahneman kind of, type 1 and 2 system kind of thinking and
Yeah.
saying that we have some kind of perception that is basically
Yeah.
a very type 1 kind of version of the brain that is taking all the sensory input that we have.
Yeah.
And the majority of the brain, of course, like motory, intelligence, if we call it that, is reactive. It's not really deliberative, and it's not really type 2. But there is a small part of the brain that humans have a bigger part of than most other humans, which is doing more deliberative and conscious type of thinking. So some kind of reasoning happening on a very high abstraction level in some way. Would you agree so far that this is a good definition of
I like the Kahneman
is?
idea, but I still come back to because it's all about analogies. We can't talk in specifics because we don't know the details.
We don't understand.
And I do like this model of lots of predictive systems running in parallel, and really then some of them bubble up. So what do we do in our lifetime? We try to learn. We have values imparted on us, right? So we have values that are inherent to us, and we have values that culture transmit to us. And those values will help us decide when all of these predictive systems are saying this is happening now and so on. You've said, no, don't keep drinking the beer because, you'll get drunk and so on. So if that value thing is somehow learnt, and then it's able to guide the I have different urges, one saying take beer, and I have another one saying something else, and they're competing. Yeah. But what I've learned through life is that I've learned how to decide which ones, and some value is driving that behavior. Yeah. Now that's different to. It's a little bit more nuanced than Kahneman, which is the world is 1 and 2. It's like,
it's a continuous kind of scale.
Of course, it is a continuous scale, and Andrew Ng, said also, things that are done in less than 5 seconds will be just deep learning and so on. But I think. I did it when I was younger. I did a Vipassana meditation. It was like 7 days without talking to anyone. And what you did in that time is you were told, just focus on your breath and your nose and nothing else, and empty your mind. And what you notice is that just things pop up all the time.
Do you still do meditation? I do every day, actually.
Do you? Fantastic. Yeah. No, I ran a meditation society in. I can tell it a little quick story. I ran a meditation society in Ireland at Trinity College. The guy from China went back arrested by the government and Falun Gong, and I managed to organise a campaign to get him released. So I was really happy with that. Very proud of that. But anyway,
speak about that in the afterwork.
Yeah, but I do think that meditation and understanding how your brain works and how you react to stimuli and to urges and so on gives you some insight as to what consciousness is.
But don't you think consciousness is a bit over-romanticized in some way? Is it really that complicated? It's just neurons, firing, but on a more higher level of abstraction, and that's it?
It's mechanical. I totally agree. It's mechanical. Yeah, and we don't understand it. Yeah. It's fascinating, isn't it?
But
I just having listened to too many like Lex Friedman podcasts and whatnot, and he I think over romanticize what consciousness is, and I think it's not really that something special.
I think we'll build consciousness.
Yeah,
I really do.
And okay, and if we now go, is AGI and consciousness related? So when we talk about trying to put a definition on AGI versus narrow intelligence, is consciousness part of this way of understanding what AGI is? Are we saying that AGI means that the computer is conscious, or is it something else?
I think we will know consciousness when we see it. It's an independent thing with free will, deciding that it's going to do things based on the values imparted in it. I think. And it'll be able to absorb culture and values from its environment, Yeah. So, obviously, the problem computers have is their embodiment. If they don't have the body to do anything, they're not going to be dangerous. But if they're given a body that can endanger us, sure, that's big trouble.
I just remember a quote. We all heard it before. You know how they say it, fake it until you make it. Mm-hmm. So, with GPT-3, we are faking it, right? So keep faking it until you're making it. Is that how we get to AGI? You're trying to do something which is sort of human-like. It's not real. It is sort of something superficial, but at the end, it becomes so good.
I don't know what your take is on it. I love reading popular books like Jeff Hawkins or whatever, because we're living in exciting times, right? But we have no idea how much we don't know. Exactly. It's like the unknown unknowns. We do not know the basic function of. I mean, we know some things about the brain, but we don't know. So there's so much we don't know.
Exactly.
And I don't know. Do we need to know the brain to be able to build conscious AI? I don't know. I don't think so. I think it's mechanical,
I think so,
but we still know that there's a lot that's missing.
Yes.
And we don't have any general theory to guide us. It's been all engineering, which is kind of cool.
And what do you mean with all engineering? Trial and error, trying to solve one problem at a time, and then you have a major breakthrough that you didn't really understand how big it was.
Take the atomic bomb, right? It was like, we fused, we split the atom, Ernst and Rutherford split the atom, and then people realized that we can trigger this. And the theory comes first, and then the Manhattan Project, knocks it out. In our case, we're going to build it first, and then the theory will come later.
Yeah, it's the Roman bridges.
Okay.
They could build bridges and arches before the math was there.
All right, there you go. And I think it probably will be something like that, yeah. I suspect. I don't know, I might be wrong. Maybe someone will come up with some great theory.
So it's engineering-led, that we will build a fucking bridge and then the mathematicians will work on it.
Well, so far it's been like that.
For 1,000 years until they can prove it.
You don't know. Like, that's the kind of cool thing about a space like this. You don't know, Yeah. I think what's cool is that when you see something really innovative, a lot of people will be in denial for a long time. And, it's hard to let go of your firmly held beliefs. And that's something that you really have to train hard at.
But maybe that's a little bit what I meant with fake it until you make it. We will make things more and more smarter and intelligent. And maybe we will have done something we didn't realize that we are beyond the threshold, sort of thing. We use progression, and then one of them progressions is a leap. And we have been doing them. We continue in that trajectory. And all of a sudden, we realize later, oops, the real switch was... 2 years earlier. We didn't realize this.
Yeah, and then it's too late.
Cool. The time is flying away. I think we need to wrap it up a bit.
We're on some sort of record time going.
Oh, sorry.
It's amazing, Jim. Great fun.
Jim, what's next in your life? What's next in Hopsworks? What's coming up in coming months?
Yeah, I'm teaching a course actually, large scale machine learning, deep learning at KTH. Yeah. So I'm back teaching.
Open course or just?
No, it's at the university. It's master's level course, so that's kind of cool.
But you're back teaching?
How? Yeah, well, because I've been on leave from the company, and then with the company, we're, it's really about Anders, like the challenge of like really breaking through, and it's a new segment, and we really have to. Execute. It's like we've been working on new ideas and new segments, and now it's about execution. That makes it's a lot of product-led work, and I've gone more. We've had a GTM team in. I'm working more product now these days, and marketing and a bit with customers, but not as much as before. So I'm busy. I'm kept busy.
That's good.
But you're having fun, right? It seems.
I think so.
Cool. Yeah.
I mean, it's cool. It's a really cool. Nice, interesting. I mean, it's an exciting times to be in the space.
Yes, of course.
And who knows? Maybe the cryptocurrencies will take over, and we'll stop talking about AI. Who knows?
Oh my God!
Don't swear in church.
Let's talk about blockchain, and then you get Anders really aroused.
I think him as well.
We joked there. I don't think so. But I think it's changing the world, and I think it will continue for quite some time.
Blockchain or what?
No, AI.
AI.
Oh, come on.
I was thinking.
We're starting on a. We are finishing on a high.
Was he kidding a bit?
No, come on. Blockchain.
The whole show was ruined with. It will continue to grow. Blockchain.
Let's us blockchain skeptics continue speaking afterwards. Okay, Jim. Anyone that you would recommend to come on this show? Someone that you would like to listen to?
Oh wow, that's a great question. Martin Nielsen. Martin Nielsen is the person you want to talk to. He's
the brain guy.
He's a brain guy. And Martin was a math savant as a child, and he's one of these lone wolves who does stuff in isolation, but he does some brilliant stuff. And Sverker Jansen as well at Rice. Both of those guys are extremely well read about AI, and they have very interesting opinions. about moving to that. So either of those two will be really, really good.
Give my best if you speak to Sarkar. It's a long time since I met him. But
Yeah. So they're both kind of very forward-looking people, I would say, in the space. And Martin has done some incredible work on the hand embodiment problem actually as well. So he could explain that in more detail to you.
Awesome.
Super
Thank
cool.
you very much. And thank you for coming to this podcast. It's been a pleasure. And I love to continue discussions now in the after work.
It's been all mine. Thanks.
Awesome, Jim. Thank you very much. Bye.
Thanks, Anna.